Hello, good morning.
Hello, have you
Good
started the
morning,
meeting?
Jerome.
Yes, I did. I did. If you don't mind, great. So we are recording. So let's start. So good morning, everybody. I will shortly introduce myself, Jérôme Gavillier. I work at SRIA, the French Atomic Agency, as a European program manager. But I am also interim director of EMIRI, which is a European Industrial Research Association that is related to materials for energy. And so in this capacity, I'm very glad to welcome you to this SRIA validation workshop, which is actually the result of an extensive consultation process that has been going on for quite some time now. And I also know that many of you have contributed actively to this process. So I would like to thank you very much for this effort first, and this on behalf of the whole IAM4EU team. And then just simply, I would like to wish you a very enjoyable workshop. So please enjoy all the presentations. And don't hesitate to be active in the Q&A sessions and the surveys we will be proposing you. So don't be shy. And this being said, I will just hand over to to Andrea Ferrari, with who I am co-chairing this workshop. Thank you.
Thank
Andrea,
you,
all yours.
Jerome, for the introduction. Hopefully everybody can hear. If you have any problems, please do contact Gemma Garcia and she will try to sort things out. And we can go to the agenda of the workshop. I'm here representing IMI, the new Innovative Advanced Materials initiative that will spearhead the IAM4EU partnership. So if we go to the next slide, Jerome, slide 2.
Yes, I will. So we will have Andrea presenting first and giving an overview of the IAM4EU partnership and the IMI association. And then we will have companies, 4 of them, just sharing their views on how they see this initiative and which benefits they are expecting for their own organizations. And then we will dive into the core topic of the day, which is the SRIA, the Strategic Research and Innovation Agenda. I will be giving you some outline first and with some practicalities, because then we will go to a more dynamic mode of presenting information to you and then giving you the opportunity to react, ask questions, and also we will survey you on these different priorities that we will be presenting you. That will be split, as you can see, in 3 sessions. We will explain you the logic behind later on. And that should take us all the morning with the breaks that we plan to have around noon. And then we will all come back for a general plenary session, let's call it, where the floor will be open to any type of question. So we will take the time to take those. And finally, Andrea and myself, we will go through the next steps, give you some more visibility and conclude the workshop. So we are for 4 hours now exercise all together. So again, enjoy the event. And I will now again hand over the floor to Andrea to present us
Yes, thank
IAM4EU and
you.
IMI.
Yeah, thank you, Jerome. If we can go to the next slide. Yes, so the session is being recorded. The slides and the recording will be available after the session. And there is a Q&A panel in Zoom where you can submit your questions. You can also test it now if you want. We will also download all the questions and we will take them as an input for the SRIA revision and address some of them if we could not do it during the workshop. If we go to the next slide, Okay, so I am going to give you setting the scene, so reminding ourselves about the upcoming co-program partnership under Horizon Europe called Innovative Advanced Materials for Europe, IAM4EU, and also the private side association, that is the Innovative Advanced Material Initiative, IMI. So the partnership is a partnership between the Commission and IMI, and that is called IAM4EU. If we go to the next slide, the guiding principle is to ensure that there is a European leadership in advanced materials innovation for an enhanced industrial strategic competitiveness. It is driven by the challenges and the needs and the priority of Europe as outlined in the Green Deal, and it supports strategic actions of outlined in the EC communication, Advanced Materials for Industrial Leadership. And we want to establish and maintain a cross-sectorial, multidisciplinary, Europe-wide research and innovation ecosystem that works across innovative advanced materials and the industrial value chain to accelerate the time to market of sustainable, innovative advanced materials and associated technology for the digital and circular economy. These are all the keywords, but they are important keywords because all the work we will do is related to those. Then we need to ensure that the priorities are driven by the industry needs and the commonality between industry sectors with an emphasis on transversality, so to try and address multiple industries. And after my talk, I will introduce 4 industry representatives who will give their take on this initiative. And we also want to approach a technology-neutral approach that is for all the innovative advanced material. We want to recognize their potential for a specific targeted application, but not only for one. And of course, we have to look at the full innovation cycle. So if we go to the next slide. Next slide. We are still in the same, Jerome. So important to set the scene and the definition. What is the definition of innovative advanced material? Innovative advanced material is an enhanced form of classical material where the properties are tuned for improved performance in specific applications or to enable totally new application, or 2 novel materials enabling improved performance or new application. So the term innovative emphasizes the commercial potential of these materials or refers to modification functionalization used to generate novel materials or innovative ways to use classical materials in new application. And the associated technologies are the complementary digital and physical technology needed in some of the steps of the industrial value chain, ranging from the design to engineering to production, process, maintain, and so on and so forth during the process. And the cross-enabling technologies are the complementary digital and physical technologies that are transversal to the entire value chain, such as those linked with the digital infrastructure, the materials common, the modeling, and the characterization and testing. So if we go to the next slide. So what are the objective and the expected impacts? At the beginning, we will focus on the 2025-2027, which is the Horizon Europe strategic plan. So the general objective is to get a leadership in Europe in advanced material innovation and industrial competitiveness, and the impact is on the twin green and digital transition. And then the specific targets, objectives are development of new innovative advanced materials and associated technologies. This will have impact on resilient and circular industrial value chains from the design, from the birth of the material, when we mean design, even the theoretical design of the material, to end of life. Then we will address the cross-enabling tools and technologies, and that will enable Europe to achieve high-level capabilities in this area. And of course, this is for this will form ecosystem enablers and synergies. And so we have a robust, comprehensive innovation cycle from low to high TRL. We go to the next one. And for this reason, we are in the process of creating the Innovative Advanced Materials Initiative. This will have a general assembly, and as soon as the article of associations are incorporated, we will be able to launch the call for positions in the executive board and in the partnership board delegation. And this will work together with the European Commission in order to define the topics to be funded over the next few years. It has to be said that for the Work Program 2025, this was done by the acting executive board that is mostly present today, giving the presentation. We will come back to this at the end of the presentation today. So if we go to the next slide, I think I really want to stress these two breaking good news. You may be aware that the Draghi report was published a few days ago. And I think in page 62, the Draghi report calls for increased funding and build a new partnership for advanced materials. And the reference 24 is the communication on advanced materials for industrial leadership. So this initiative is really focused and targeted by the Draghi report. And also quite interesting, the new commission, the mission letter sent by Ursula von der Leyen to Katerina Zarieva, the new commissioners for startup research and innovation, calls for a Advanced Materials Act to be created to support the research and innovation process through manufacturing and deployment. I think these two sort of, one political and one sort of advisory call to the Commission make us confident that innovative advanced materials will be really at the core of what is happening in the next few years. And the ambition of IMI as the association is to represent the community in all the discussions with the European Commission on that. Thank you. So I think this is it for my part. And we are going to state that the Innovative Advanced Material Initiative vision and ambition is that by 2035, the European industry will develop, produce, integrate more rapidly innovative advanced materials that meet increasingly stringent applications, shorter technology lifetimes, and leading the global innovative advanced material competition. And so we want to maintain and establish a cross-sectorial, multidisciplinary, collaborative, European-wide research and innovation ecosystem that will accelerate the time to market of safe and sustainable IAMs and advanced materials. Again, the ambition is large. It's for Europe to become the world leader in innovative advanced materials. And what we are taking today or these days is the first step for this to happen with IMI, IAM4EU, and the potential other actions that we considered. I will now stop my presentation and ask for the endorsement or comments from 4 industrial leaders who have agreed to be here today to speak with us about their view on this action. The first one is Fabrice Stassen from Umicore. Fabrice, please go ahead.
Yes, so good morning, everyone, and welcome to this validation workshop. So I guess you're going to be stuck with us for a couple of hours. So get ready and try to enjoy as much as possible this session. So my name is Fabrice Tassin. As Andrea said, I have the honor to be part of EMIRI, which is the Energy Materials Industrial Research Initiative. And I'm also coming from the company Umicore, which you may know as a global player in the field of advanced materials, mostly for clean mobility, active materials for the cathode, electrocatalysts, catalysts for clean exhaust pipes, or you name it. So we are very happy to support this initiative. The point that I want to make is that we have come quite a long way. If I remember well, at Umicore in mid-2021, when we got a call from the former Commissioner Cabinet asking us to start thinking about what should be an advanced materials strategy for 2030. And this is where it all began. So it's already a couple of years ago, and we have come indeed a long way. I will not go into the details of all the challenges that we see in Europe, because this is very well documented in all the documentation that we have created over the past months, years with the teams. But we do have some challenges in developing, deploying, and in industrializing quite fast the advanced materials that have to be innovative in order to be able to compete globally. So we are very happy to see that this is now in the mission letter to the new incoming, still to be validated commissioner. And we however see that at European level, there are a couple of success ingredients, if you can call it like that, that have to be well mastered. And I see 3 of them that I wanted to share with you. The first one is to come together and operate as an ecosystem. And the ecosystem is industry, SMEs, research organizations, academics, either producing or using the advanced materials and bringing them to the final application. And of course, supporting the concept of technology neutrality, because we have a huge toolbox of materials that we can use, and we have to use it to the best we can. The second point is that we need to make sure that we have financial solutions coming to us to make sure that we can keep on doing the R&D and bring it to the industrial level. And the last point is, of course, that we have to agree on the priorities that we believe should be tailored and should be worked on by all our ecosystem. And this is, for me, the point that we are talking about today. That's the concept of the validation workshop, is to agree that the priorities that have been provided by the industry needs are those that are indeed to be tackled. And I'm happy to see my other fellow industrialists later coming to the table, and that we are going to do it. So I'm very happy to see that this SRIA is organized today. And I hope that this is going to be a quite exciting session. So last but not least, of course, I want to thank the teams that have been under quite a lot of pressure to deliver this. So thank you so much, Jérôme. Thank you so much, Andrea, and all the teams for providing these important documents. And I wish you all a very interesting session this morning. I will stay with you for the whole duration, and I look forward to the panel.
Thank you, Fabrice. We now go to Elmar Bonacurso from Airbus. Just as a note to the people listening, there are no slides for this industry endorsement. Is the sort of mission statement from the different industry. Please, Elmar, go ahead.
Hi, good morning, everybody. Yes, my name is Elmar Bonacurso from Airbus. I will start where Fabrice left, thanking especially Jérôme, Andrea, for doing all this work. I'm also part of the drafting group, but yeah, the main thanks go to these 2 people and to all the support staff. Okay, now I put on the hat of Airbus. So who's Airbus? Airbus is an international pioneer in the aerospace industry. We are leaders, we're still leaders in designing, manufacturing, delivering aerospace products to customers all over the world. So we are, in that sense, a European, truly European industry. We are based in 4 European countries, but our customers are really international. We are at the forefront of aviation industry, so we build among the largest commercial passenger airplanes. We are also a #1 manufacturer in the world of helicopters, from small to large sizes. And we are also Europe's largest defense and space company. So we have on the portfolio the largest transport aircraft, the A400M. We have fighters, we have military helicopters, we have space launchers, satellite, and things like this. So what is, or you might ask, what is our business with advanced materials? We are not a chemical company, we are not material producers, but all our products are based on the use of the most advanced materials that are available on the market, that are possibly offered to us in order to make our products, to make the best products, to make them competitive, and especially to make them sustainable. So we have, in the area of advanced materials, 4 big challenges. Just the keywords of them, which is performance. So we need highly performant materials. A big challenge is electrification of mobility, electrification of aviation and the aerospace sector. Sustainability. We cannot increase the number of passengers, the number of aircraft, the number of travels, without also having sustainability in mind and all the products, all the materials that we need for that. And digitalization, like all material developments of the future, we foresee that this will all be digital. From computational chemistry, so the basically design of single molecules, up to components in artificial intelligence, machine learning, in order to optimize and to develop innovative solutions. So these are the four pillars that we see, and this is also the reason why we pushed from the beginning, and we are involved from the beginning in this new initiative, IAM4EU, and also partnering and becoming a member of the new Industrial Association on Advanced Materials. What do we expect out of this? We expect, of course, out of this, knowing how strongly also the EU, and Andrea explained how strongly the Draghi report, Ursula von der Leyen last year in the State of the Union speech, and now in appointing a new commissioner, how strongly they push advanced materials. I think that's one of the pushes on advanced materials that has never been such clear and with such a commitment. So we expect out of this, of course, in collaboration with all of you, to be able to make successful business cases in order to develop, to design light, affordable, certifiable materials. So materials that we can also use that are accepted by the certification bodies. Of course, we need to be able to scale them up. We make large aircrafts. It's among the largest technical products in the world. We need to be able to scale up production. We need also at the same time to reduce the risk and to save design time and development time by introducing new digital tools for material design development and industrialization. Part of this is also new tools in order to trace materials, to have a materials management tool in order to empower sustainability and especially circularity and end of life of these products. So basically, all the things that are said now, so what we expect are all contained in the SRIA at one or the other place. So we are very happy with the status of the SRIA as it is now. And we are very much looking forward that we can start with this as soon as possible. Thank you very much.
Thank you, Elmar. And again, there are no slides for these four industry statements. The next one is Stephanie Nesbitt from Michelin.
Good morning. Yes, I'm Stephanie Nesbitt, and I've been part of the team. It's been a pleasure to work with Jerome and Andreas and Elmar and the different individuals that you'll hear speak this morning, preparing and to launch both the partnership and the association that will support that. But more specifically this morning, I'm going to put on my Michelin hat, and it's a pleasure to really share with you this morning why, from the Michelin perspective, the IAM4EU, the new partnership on innovative advanced materials, and as well as the IMI association that will support that, are essential to us as a leader in the mobility sector to not only remain competitive and resilient for the future, but also enable us to achieve our future ambitions with respect to growth beyond the mobility sector. First, Michelin has significant ambitions for materials with respect to circularity, and more broadly to sustainability. Specifically, we have an ambition to be able to achieve 100% recycled and/or renewable materials in our products by 2050, with a midterm target of 40% by 2030. The development of the necessary circular value chains will be essential to help us achieve this target for the over 200 raw materials that we use every day to manufacture our tires. This strategy relies on the development of a strong ecosystem from partners that would start with the industrial side, small companies, medium-sized companies, startups, universities, and research institutions, as our ambitions can't be achieved by a single company alone. Secondly, one of the missions of IAM4EU partnership is to help significantly accelerate the time to market of sustainable, innovative advanced materials. Creation to and access to infrastructures will be essential to this acceleration, enabling the rapid scale up from the laboratory through industrial employment. Michelin has been working in collaboration with several public and private institutions to transform an industrial facility in the center of France to help bridge existing gaps in this access to infrastructure. The technology park will offer companies of all sizes, as well as different research partners, access to analytical chemistry, process simulation, and engineering platforms, and longer term also access to an open platform for biotechnology, which will enable scale up of innovative products and processes. The long-term objective is to build a strong local ecosystem, helping bridge the gap from the laboratory to scale up. However, we're only one company in development of the necessary infrastructures and associated ecosystems required to assure the ambitions of a resilient, competitive, and sustainable Europe will require a concerted effort at a much larger European scale. So those are just two reasons why the IAM4EU partnership and the IMI association will be important for Michelin to help us achieve our future ambitions. So thanks so much. And I turn the hand over to, I'm not sure who comes next.
Yeah,
Amia?
thank you,
Yes.
Stephanie. And we now have our champion for SMEs, Amaya Zutuza from Graphenea.
Hello, good morning, everybody, and thank you for giving me the opportunity to share the view of SMEs here. I would like to also start by thanking Jerome and Andrea. I mean, at the end, this final result, well, it's not really the final, but close to final, has been the end of a lot of hours of work, so I'm also very grateful. Graphenea has been involved from the beginning, so I've seen everything, the evolution, how it has been shaped, and it has been a great opportunity for Graphenea. Graphenea is a graphene material producer, and we also fabricate graphene devices and offer graphene foundry services. So as you can see, we are relatively early in the value chain. But I want to stress and try to encourage a lot of SMEs to be involved in this new partnership, IAM4EU, but also in the Industrial Association, IMI, because I think it's an opportunity for SMEs to be heard, to define their needs, talk about their challenges. At the end, a lot of SMEs will have very common issues and challenges, so I think it's an opportunity to be heard, to be able to work also with large industries, and at the end, we are much stronger working together. And we also have the opportunity to shape the strategic agenda around innovative advanced materials in Europe. So if you are involved, you work, use innovative advanced materials in your work, in your industry, doesn't matter what part of the value chain you are. I mean, we really need you, and in order to shape the strategy, we need all the SMEs that can be involved. And yeah, it's a great opportunity. So I encourage everybody to join. Thank you.
Thank you, Amaya. And hopefully this testimony from large and small, medium enterprises show the support that this initiative has from the European industry. We now move on, and Jerome will introduce the details of the SRIA, setting the scene for the second part of the workshop. Jerome, please go ahead.
Indeed, thank you. So yes, we have had this overview of the high-level part, let's say, of the initiative, and also have had some testimonies of our industrial colleagues. So now we will go, let's say, one level below, looking more at the implementation aspects of the initiative, which are set inside the Strategic Research and Innovation Agenda, the SRIA. But first, I would like to start with another layer of objectives. You have been presented the general, overarching, and the specific objectives that have been set onto the partnership, but there is a lower level, more practical, about operational objectives that are set onto the association. And these operational objectives, to say that they are still subject to adjustment, but here they are, and they will give you some idea of what we have in mind and what we want to achieve from the association side. So these operational objectives, we have 10 of them, and they are distributed across the 3 specific objectives, and I will shortly present them one by one. So first, for the first specific objective, we have this objective 1, which is a primary objective about fostering competitive, innovative, advanced materials along with their associated technologies. So this will be about delivering use cases and demonstrators by the end of 2027, which will in turn contribute to the later outcome of enabling resilient and circular value chains, which is actually what we are foreseeing by the end of the next framework program. So sometimes in 2034-35, and which is the date at which we set the vision, as it was said earlier. And objective 2 will be about setting up a SRIA, which we are currently doing. We are delivering you now the first version of this agenda, but also to maintain this agenda of the years and deliver an updated version of the agenda by 2027. So basically, this agenda will be the framework inside which we will launch all actions and different types of actions that will be either supported on the public side via Horizon Europe, but also on the private side through in-kind contribution. And these activities are taken all jointly. They will contribute to achieving all these operational objectives and specific objectives. So then we move to the specific objective on the cross-enabling tools and methodologies. The objective 3 is about materials digitalization, materials data, and data management. So this is here about facilitating the development of a federated digital materials data space that will be supported by the so-called materials common infrastructure. Then objective 4 will be about digital tools, machine learning, artificial intelligence. So that will be about accelerating the design, the development, the production, processing, and transformation of innovative advanced materials that are to be safe and sustainable by design. Objective 5 will be connected to the previous one, and this will be about setting up this user-friendly SSBD approach for innovative advanced materials. And then last, we move to the ecosystem specific objective. So there, objective 6 will be about bridging the gap between academia and industry through connected R&I action. So what we want on one hand is to be sure that research is driven by industrial needs, but also the other way around. We want industry to valorize and exploit research results. Objective 7 will be looking at the stakeholders at the ecosystem in the larger sense and beyond research and industrial actors, because we'll have to consider other types of actors, for instance, as intermediary organization, being clusters, associations, platforms, and so on, but also regulators, investors. So this is actually a full comprehensive ecosystem that we want to set in place, and this along all the industrial value chains. Objective 8 will be to go towards circularity. A major objective for the partnership. So especially focusing on aspects related to the recovery, recycling, and reuse of advanced materials, and how we can possibly set up supply chains based on secondary advanced materials and raw materials. Objective 9, which will be tightly connected to Objective 1, this is about the adoption of all those technologies, their scaling up and their deployment broadly across sectors by the industry, with, and it was said earlier, with a focus on SMEs, because SMEs, they are innovation vehicles that we need to support actively and to help them in accelerating their business and reaching their markets. And the last objective, 10, will be also quite important. And there we are planning to bring a substantial contribution to standards and norms in the European Union.
So Jerome, Jerome, 1 second. So Jérôme is going to 001, 002. You see at the right hand, there's a few questions on that, while we are still within SO1, SO2, SO3. So now when he commented on objective 10, it was about 0010. That is at the end of the slide. So hopefully now it's clarified. Please go ahead, Jérôme.
Yes, thank you. So 3 specific objectives. I didn't take the time to read them because they were introduced earlier by you, Andrea. Okay, the innovative advanced materials and associated technologies, the sustainable and resilient value chains. S2 about the cross-enabling technologies and methodology, and the third one about the innovation ecosystem, and then the 10 operational objectives. But you got it. So the next slide now, we are finally getting into the SRIA. So here you have the outline of the document, which document is under finalization and will be made publicly available soon. So soon it will be in your hands. But here just giving you a glimpse into the structure, the outline of that document. So it starts with some introduction, where we set some definitions on the innovative advanced materials, but also on the associated technologies, the cross-enabling, the cross-sectorial technologies. So that was briefly introduced to you already. Then in the second part, we are introducing the major policies under which we are actually developing this initiative, being the strategic plan for 25-27, but also importantly, the EC policy communication on advanced materials for industrial leadership. And we are also developing the areas of applications that are concerned by these policies. In the part 3, we are making some focus on the 4 priority areas that are mentioned inside the policy communication, which are energy, electronics, construction, and mobility. And there we give some general features about the market size and trends for these 4 areas, but also general information on the needs and challenges of innovative and advanced materials. We also tell a bit about the expected impacts. And finally, we define, or we describe what is the EU innovation capacity currently in Europe. Then we jump to the 3 next sections, which are actually connecting directly to the 3 specific objectives. So there is really a symmetry between the SRIA outline and the specific objectives. So section 2, innovative advanced materials and associated technologies. First, we start introducing the importance of exploring in the first place and developing and upscaling materials that have a high value functionalities that are ever more performant, and we need to push the envelope. We call for disruption, and this is all very important to support innovation leadership in Europe as well as industrial competitiveness. But also importantly is to endorse the digital transition, to adopt all digital tools being available, so to be sure that we can go faster, but also that we can go better understanding, generating new knowledge, and better understanding the nature of the materials, better understanding the properties and the opportunities these innovative advanced materials are offering us. The second part is directly related to the Green Deal. So there we are presenting the Green Deal, in a few words, shortly, the Green Deal and all associated acts, action plans, regulations, and directives that will all together frame the future requirements that will be set on advanced materials. And these requirements are to be quite stringent. So we are there setting the importance of addressing this dimension, and parts 1 and 2 taken together actually supporting again innovation leadership and industrial competitiveness. That will be the sine qua non condition to actually secure open strategic autonomy for Europe. Part 3. This is where we are presenting the R&I priorities on IAMs and associated technologies. So that will be our session 1 in shortly, in a few minutes. We will start diving in this session 1. Then section 3 on the cross-enabling tools and methodologies. So there we are presenting additional R&I priorities, which are split across the 3 parts you can read on the screen. Firstly, materials knowledge valorization through digitalization. then materials modeling, characterization, and testing. And last, embedding safe and sustainable by design. And finally, the section 4, which will be section 3. This is about the ecosystem enablers and synergies with the other partnerships, other programs and initiatives currently in place in Europe and not in place. So there we will have more R&I priorities that will be split across 3 parts again. First one being on stakeholders collaboration. Second one on fostering the production, use and reuse of advanced materials. And finally, the standards and norms. So that's about the outline. And now we will dive into these different R&I priorities. But just beforehand, and I will take another 2 minutes, I will share with you some practicalities so that you will understand how we are going to proceed. And then we will start. So we will present you the R&I priorities. You understood this, and we will go session by session. In total, we have 21st R&I priorities, which will be quite an extensive and exhaustive exercise, but we will process them one by one. You have understood that they are organized, split in three groups, 3 sessions, aligning with the specific objectives. And then once we have presented all priorities within a session, we will stop and we will start interacting with you. So there will be first, I think, an online survey, a Mentimeter type survey. It's a Zoom one, but we will ask you a few simple questions. So if you can answer live, it would be great so that we can collect and then discuss a bit the results, the consolidated results. And then we will open the floor for Q&As. We will have a moderator for each session. And these questions will be basically about you voting on which R&I priorities are relevant to your organization. Put yourself in the shoes of your organization, yourself. We will ask you about your interest in the different priority areas, the 4 being in the focus of the communication, but also others. And also we will ask you about private investment. And last, because this online survey is just a quick exercise, we would like to capture some more information from you. So we are proposing you an offline survey that will be presented to you at the end of the 3 sessions. You don't have to complete it online, so no panic, take your time. We will give you a few working days to complete it, but there we will question you and ask you for some more detailed information. And as you can read, that will include information at IAM and product levels, the type of support you are expecting from the partnership, the level, a bit more quantitatively, what level of private investment you are foreseeing for your organization. And that's about it. So these practicalities are being shared. We will now start the show. I don't know if you have any points to make before we start with session 1.
Okay, thank you very much, Jerome, for the introduction and the practicalities. Again, if something is not clear, please type in the Q&A or contact Gemma Garcia directly, and we will try to address you directly during the presentation. We now start a question if we are parallel or a sequential session. Everything is a single session. We are not going to have a parallel sessions today. So it's going to be a bit heavy, but we felt it is important to give the opportunity to all the participants to be present in all the different discussions. So we start with the first session 1, that is Innovative Advanced Materials and Associated Technologies. And the panelists will be Jerome, Francesco Bonaccorso, Elmar Bonaccurso, Amaya Zurutuza, and Eva Schillinger, and myself. I will also act as the moderator for this part. And I will ask Jerome to start on P1, 2, 3, 4. Please go ahead, Jerome.
Indeed. Thank you, Andrea. And I will open this session with a table with this slide, which is a summary of let's call them the overarching needs and challenges on innovative and advanced materials that have been highlighted for these 4 priority areas. So this information you will find in the introductory part of the SRIA, which I mentioned earlier. And basically in very short, and then we can read it together, it's showing you where these needs and challenges lie. So on the energy side, we are looking at renewable and low emission energy. Not surprisingly, we are looking at advanced energy systems and infrastructures. We are looking at transformation of energy-intensive industries. On the mobility side, low carbon mobility, electrification of terrestrial, marine, and air transportation. Elmar touched on this already. On the construction side, that will be about energy efficiency in buildings and construction, but also on safety, protection, comfort, and preservation of heritage. And last, about automation and digitalization. And for electronics, it will be about cutting-edge electronic, optical, photonics, and quantum technologies, as well as digital connectivity. And then in red, you see the priority numbers for this session, 11 of them in total. So here the point is just to show you that these priorities are not only covering these 4 priority areas, but they are jointly covering them, and also importantly, they are cross-sectorial, they are cross-applications, and that's in the spirit of IAM4EU, where we want actually to maximize impacts and to be sure that anything we are supporting in terms of IAMs and associated technologies and methodology and cross-enabling tools will benefit not only one sector of application, not only one application, but several. So now, it takes me to the priorities, 21st of them, 11 priorities in this session. So let's kick the exercise and to say indeed that the 5 first priorities could be well gathered under the umbrella of clean energy technologies. And these first 2 you see on the screen, they are actually about the production of energy, being electrical energy or heat, the production of energy carriers, being hydrogen or synthetic fuels, and also the production of fine chemicals and additives. And so these 2 priorities are about, as you can tell, read about electrochemical processes and systems. And they are focusing on 2 key components of those systems, which are on one hand the catalysts, and on the other hand the membranes. So as per the catalyst, priority 1, we will be looking firstly at the CRM, the critical raw materials content of this catalyst, because this is a very critical point for this type of materials. We want ideally to get rid, but in the best case, to mitigate, to reduce the content of CRM inside the catalyst. And these catalysts, the novel innovative advanced materials we are looking for, have to be primarily, and this is a prerequisite, non-toxic, of course, but they are to be also recyclable, which is quite a challenge when you know how tiny, how small these catalysts are and how dispersed they are inside the system, inside the electrochemical cells. Also, we want this catalyst to be highly performing. And in terms of performance, what we are asking for catalyst first is to be active. So to be active as possible. So we will be looking at high activities, but also it is so important that the catalyst is selective to the molecule we want to convert, to transform. So selectivity is a very important property, excuse me. We also want this catalyst to last long, and so to be stable in their environment. And additionally, we would like to have catalyst solutions that can operate at lower temperature and lower pressure, and this simply to reduce the energy budget we are putting inside the electrochemical reactions, and so to be more energy efficient. And also interesting is to look at renewable innovative advanced materials for making these catalysts, excuse me. And there we are thinking of biosourced catalyst. And finally, sorry, there is some alarm sound on my side. It's a bit perturbating. And last, what is very important, whatever the type of catalyst and whatever the type of application, what is really needed now is to speed up the exploration and the discovery of new materials to implement a high throughput material acceleration platform means so to better explore the space of these types of materials and to be able to put and to develop and to upscale new solutions. Now coming to priority 2, related to the membranes, we will be more specifically looking at ionomers, so being polymers, copolymers that are functionalized with ionic functionalities, and these for different types of exchange membrane, being either proton or anionic exchange membranes. And there also we need advanced properties. We need to improve notably the ionic conductivity of those membranes, but we want them to be very selective in terms of which ions they let permeate. I'm sorry about this alarm. We want this membrane to be mechanically strong because of mechanically strong and durable, so to have a long-lasting components, and we want them to withstand conditions that are sometimes quite aggressive regarding the type of materials they are made of. So that being temperature-wise, but also electrochemically wise. And so that's about these 2 priorities. And then I'm moving to priority 3. So there it is more about energy carriers storage, presently hydrogen, but also about thermal energy storage. So in terms of hydrogen storage, you know, there are 2 means to store hydrogen. One is solid state storage. So there we will be looking at safe and sustainable solutions on materials of the type of metal hydrides, complex hydrides, and porous innovative advanced materials. And on the other side, we have the gaseous phase storage of hydrogen under high pressure. And there we will be looking at very different types of materials, obviously, which are mostly composites, thermoplastic-based, fiber-based composites. And they have to be lightweight because, forgot to say, but for hydrogen storage, we are also looking at mobility application. So we want lightweight. We want strength. We don't want to have any issues with these storages. And we need also a good barrier performance for this storage under high pressure. So And then we move to the second topic, which is about thermal energy storage. So there we are looking, good, the alarm stopped. So there we are looking at latent heat storage, which is enabling much higher heat storage capacity, density when compared to sensible heat storage. So we are clearly looking at these so-called phase change materials. And there is quite a wide range of materials on the organic side with paraffins, on the non-organic side with salt hydrates, and there are also hybrid components. And these PCMs offer the advantage of having different types of storage, which can be quite dynamic ones with a short period of time of storing heat, but they can be also seasonal. You can store it across seasons when you are using salt hydrates, for instance. And what we are looking for there are materials that are first safe, because if you take organic ones, for instance, they are very flammable. So we need safe solutions, but also we are very demanding on the properties side of these materials because we want them to be highly conductive thermally, because you want some good dynamics in the storage and releasing of heat you need to conduct heat properly, and we want them also to be lightweight and to be integrable into complex storage systems. And last, and this is about heat exchanges, which is very important in the industry and which is very key to improving energy efficiency in large systems and at the large scale. So here we are looking at smarter heat treats. Again, obviously, we want them to be non-toxic. We want them to be low viscosity for energy efficiency reasons. But we also want them to be, in the first place, thermally very efficient, high thermal conductivity, and also be able to operate at a high temperature for certain specific applications. So that's about priority 3. And I will finish with priority 4, which is about magnets. So magnets, permanent magnets, high performance permanent magnets. So those materials are absolutely key, absolutely important in terms of energy efficiency in systems of a wide variety. And they are key in different applications that cover, for instance, power generation, traction motors, motion control in robotics, transport in general, medical devices, and so on. And these materials actually enable a very high magnetic fields, while at the same time, they have a very small volumetric footprint. So they can enable high capacity at the system scale. But the issue with these materials is mostly that they are highly dependent on critical raw materials. They are highly dependent on a few of the most critical rare earth elements, and they are also dependent on other critical raw materials, as we are using additives and coatings for these magnets to make them more stable. And so this is why these materials are so strategic in general and so strategic for Europe, because there is no existing alternative to those materials. So now there is a way to improve the situation and to go towards CM3 and CRM leaner permanent magnets. And this is mostly at the materials level, investigating and exploring new compositions and new phases of the materials, but also working at the microstructure level, so to enable new materials compositions, structures that will enable the same performing, but with less critical raw materials. And at the second time, we need also to act at the more macro level by designing these magnets in tight link with the application and with the system that is considered. So to be able to maximize the performance and the energy efficiency we will get out from the product eventually. So there should be a tight co-designing of the materials microstructures with the macro design of the product. And also importantly, and I'm close to the end of this priority, very importantly is design magnets and systems where we will be able to disassemble things, disassemble the components, retrieve the magnets, and recover those magnets for secondary use. And this goes together with this. We will also encourage in the making of magnets and magnetic systems to use a high share of secondary magnets and magnet components in the future. So there is some work to do on the processing side of things, but also on the manufacturing side of things to reduce the waste related to the production of magnets. So that's about priority 4. And now,
Okay.
I'm finished.
Yeah, thank you very much, Jerome. In the meantime, I invite all the participants to start putting in the questions on these priorities. If you don't like them, if you like them, if something is missing, if whatever, we will have a chance of discussing with the panelists after they have presented. The section one will be the more, let's say, technical one on what type of materials and technologies we are going to do. So please, if you don't like them, if you have any comments, do type and we will address.
Andrea,
now,
Andrea, just shortly, we take comments, but if you like or not, please just wait for the online survey. That will be the time for you to tick boxes if these priorities are relevant to you or not. So please, for your comments, just qualitative comments.
Or even quantitative comments.
Or quantitative, but not your liking or not liking. Thanks.
No, yeah, that will be done in the survey. Okay, good. So now I introduce Francesco Bonaccorso from Bidimensional, and he will discuss about priority 5. Please go ahead, Francesco.
Thank you, Andrea. Thank you for the introduction. And as Andrea mentioned, I'm Francesco Bonaccorso from Bidimensional, that is a startup company based in Italy that is producing and commercializing high-quality 2D materials. And together with Andrea, Jerome, and all the drafting group, we work in the last several months in defining these priorities. In the priority number 5, essentially, it is quite broad and is covering innovative electrolytes, binder, and separator for electrochemical energy storage. Essentially, the application area that is covering this priority is quite broad, covering, of course, energy for energy storage, but also mobility for the recyclability and second life of electric vehicle batteries, and also electronics. Is recalling words, of course, are circularity, safety, and recyclability. In all the applications that I'm going now to discuss more in detail, very briefly, these words are the most important one. Starting from the electrode, essentially, innovative material is extremely important because then we can have a strong impact on defining next generation batteries. And the key target will be on materials from recycled sources and focusing on critical raw materials option. The typology of batteries that will be essentially the center of the calls is quite broad, from lithium-ion batteries, sodium-ion batteries, potassium-ion batteries, but also other chemistry, like, for example, lithium-sulfur batteries and metal iron batteries. And the key performance indicators essentially are, of course, getting high thermal and, most importantly, electrochemical stability, getting batteries and designing batteries with high energy and power density, looking at fast charging, and of course, again, safety and cyclability are a key point here. Going more into details in the electrode, for what concern anodes, so the focus will be on dendrite-free alkali metals, the applications of nano-engineered composite, anode-free cell to enhance the capacity, efficiency, safety of the cell. And in particular, for anode-free cell, there will be the opportunity to eliminate the permanent lithium metal anode. This kind of cell operates with lithium that acts as a charge carrier. This kind of cell essentially require solid-state electrolyte, and the cathode that can be applied are quite broad. The most common one, lithium iron phosphate, but also lithium cobalt oxide, NMC, and so on and so forth. So, for what concerns the cathodes, the focus will be on cathode that will be produced via solvent-free extrusion process. That will be an activity that will be focused as alternative to the conventional NMP, N-methyl pyrrolidone-based cathode production. That is the most relevant one, and trying to develop new dry extrusion process coupled with advanced coating technology. This is essentially devoted to produce high energy battery. But there will be also activity devoted to the development of protective coatings, improved design for the battery, and of course with reduced environmental impact. For what concerns the electrolytes, the key effort will be devoted for advanced solid-state electrolytes, eutectic solvent-based polymer electrolytes. In this kind of polymer electrolyte, especially the transport is dominated by ionic mobility instead of the number of charge carrier, and this is extremely important to obtain high ionic conductivity. And of course, again, stability, safety will be the key point here. For what concerns separator, the activity will be devoted on the development of separators that will be coupled with advanced coating technology. Particular emphasis will be done on non-fluorinated binders, fluoropolymers free, and lignin-based membrane for ion batteries. And essentially, for what concern the systems, the advanced material are extremely important here, because all the battery component will have advances here. Activity will be devoted on cooling system. In particular, high dissipating materials are key for the cooling system. The casing, innovative advanced material, is extremely important because we can introduce mechanically strong and lighter materials. And also the fabrication will be important, because there will be a focus on 3D printing technology.
Thank you, Francesco, for the presentation. We now need to move to the second one. I remind the panelists it's 4 minutes per topic, and we go back to Elmar Bonaccurso, who is going to present P6. And if we go to P6, Jerome. Yeah, thank you.
Yeah, thank you. Thank you, Andrea. Right. So the next two, P6, P7, are somehow related topics. In P6, we are aiming, and we describe innovative advanced materials for smart surfaces and interfaces, in order then to be applied on multifunctional components. So what do we understand under responsive? These are either surfaces, coatings, interfaces that are sensing or that are producing some effects. And here we are talking about all materials that have no structural components. So they are not supporting any structure. So it's not the chassis of a car, or of a bicycle, or of a tennis racket, but what we put on top in order to make this functional, multifunctional, responsive. And here you see a number of listed number of these functionalities, like thermoelectric, piezoelectric, photoelectric, electrochromic properties. And in order to obtain them, there is a number of materials, and the list here is of course not complete, in order to fulfill, satisfy these properties that we want to achieve. And here, you see hydrogels, ionic liquids, liquid crystals, perovskites, graphene-related materials, so all the two-dimensional materials, and so on. What we are looking in, and what we are expecting from these materials is that they are highly performing. So they should be then, of course, be highly performing in terms of sensitivity and selectivity. So both need to be very high. We need to have short response times, long durability, and of course, they need to be affordable, so cost effectiveness. And again, here, keywords that are falling are smart coatings for self-detection, damage detection, coatings that are self-healing, and alike. Apart from being highly performant, being affordable, they also need, of course, to be adaptable to the various products that we might have in mind. Coatings that go on components usually or sometimes are rigid. We cannot integrate them well. So here we have to look that they are so flexible that we can put them on various substrates, that we can use different techniques that are used right now when you upscale processes, so industrializing painting processes and so on. So trying also to apply those to new 3D printing techniques and inkjet printing techniques that are adaptable to robots and that are adaptable to more complex structures, but also considering the substrates that themselves are stretchable, that are flexible. And here we're thinking about all the personal electronic equipment that are used for health control and so on. Right, so these are the 3 key points here. Let's go to slide number 7.
P7.
Oh, sorry, yeah, P7 on slide 21. And here we're talking now about innovative surfaces, interfaces, and composites for structural systems. So here we're talking about the materials that are holding the whole thing together. And here we distinguish in a few classes, like more and more important composites, so carbon fiber, glass fiber, reinforced composites will get. They are on the market since quite some time, but still they have drawbacks. There are some limits to them, and we need also here to improve them. We need to go in the directions of more lightweight designs, so saving weight. This is especially important for aircraft, of course, where weight is one main design parameter, but for any other applications, if we want to save energy in moving around structures, for example. We have to guarantee structural integrity and also maybe try to integrate functions in the structure. So to have a number of functions inside there, for example, for health monitoring, for example, for having structures that themselves are thermally conducting, thermally insulating, electrically conducting, electrically insulating, so that we don't have to apply an additional functional coating on them. And this would be also a game changer in a number of industries. Of course, they need to be apt for mass production and for upscaling. Opposite to composites, we have metals and alloys that are classical materials that are on the market much longer, but also there we are not yet at the end of the road in developing new lightweight materials that offer high strengths, that offer high resilience, that offer long durabilities, that we would be able to use also in extreme conditions like cryogenic temperatures for hydrogen tanks or also for going to space. We need, of course, now in the frame of sustainability, also look at their environmental impact. So to use as much recycled materials as possible, to try to get around or try to use as less as possible critical raw materials, because that's a source that is limited. And also to try to improve the design of this new alloys, for example, to create specific microstructures, different grains, ultra-fine grain sizes, in order also there to optimize their mechanical properties. And also metals, we can also use them in the form of powders for 3D printing, which is also a technology that has in some areas not yet reached complete maturity. So also there we need to look at the blocking point. So what is hindering the use of 3D printing, for example, for aerospace, or for example, for building and so on. And the third part, so we have composites, we have metals, and what if we want to bind them together, we need to look at the surfaces and the interfaces. Or also, if you want to protect them from atmospheric, from the environment, we need also there to put coatings on them in order to protect them from the environmental degradation. So they need to be corrosion resistant, wear resistant. They need to be able to work in extreme conditions. So if the structural materials themselves are not good, we need to protect them. And this is what we're aiming for in this in this bullet point, to think about materials for coating, processes for treating the structures in order to endow them with all these properties. Last but not least, fourth bullet point is we do all this in order also to reach and the sustainability goals through recycling, through reusing, through looking for bio-based sources, options for this material. So like bio-based coatings, and also by increasing and by improving the design capabilities that we have, and so going to computational digital methods in order to do the design of this, to design the materials and to design the processes. And here, exactly, a few key points is nanocomposite metal, ceramic metal, matrix composites, and so on. Right. Last point, standardization processes and certification processes. We also need to look at them from the very beginning of the design, but this is another priority and will be discussed later. So thank you very much.
Thank you, Elmar. And we now move to P8, and Amaya will present.
Yeah, hello. So this is a priority area 8, and this relates to the use of innovative advanced materials to reduce the use of critical raw materials, but not only critical raw materials, but also other environmentally harmful materials that are used, as you know, in electronic devices. We have a lot of CRMs and environmentally harmful materials. So the idea is to use innovative advanced materials to reduce the use of the existing materials, and also anything to do with their manufacturing processes. And here we have identified 3 different types of innovative advanced materials. So innovative advanced materials that are multifunctional electronic materials for chipless applications, like, for example, radio frequency ID tags could be one of them. And with the idea of addressing integration complexity at the nanoscale. So anything that you can use an innovative advanced material to provide a solution towards that. And at the end, I'm talking about using innovative advanced materials, but of course with the aim of commercializing them in the market, of course, yeah. The second type of material, innovative advanced material that we are thinking is using graphene and 2D materials as alternatives or additive, or in order to reduce the use of silicon, germanium, aluminum, gallium arsenide, or indium phosphide in the, let's say, in the roles they fulfill in products. And the third type of IMI is low-cost IMIs for flexible and printable electronics. So as you can see, this a lot of the priority areas are related somehow. So not a single material is covered under one priority area, but they are a bit transversal. Yeah, and that's it from my side.
Thank you, Amaya. We go to priority 9. I will present this myself. I make a small premise that in the advanced materials communication of the EC, there are 4 areas. One of them is called electronics. I want to stress that when the term electronics is used in this document, it includes electronics, photonics, optoelectronics, quantum, and so on, just to be clear. So P9 is innovative advanced materials for energy efficient, multifunctional photonics, electronics, spintronics, and quantum technology. And energy efficiency is important because, as you know, the digital devices are, for example, hardware for AI or telecommunication are one of the biggest users or the biggest increase in energy consumption from them. By 2040, there is a prediction that almost 20% of the global emission will come from this energy consumption. So we need new innovative advanced materials that can cope with this, allow the increase in efficiency of the devices with a lower power consumption. So there are 5 areas. The first one is linear and non-linear optical 2D materials and other innovative advanced material for multispectral, broadband, energy-efficient optical sensor covering from visible to shortwave IR, midwave IR, and terahertz, so across the entire optical spectrum. The second one is 2D materials and other innovative advanced materials for integrated photonic circuitry, for telecom and datacom application, for system performance improvement and power saving with miniaturization of signal processing circuitry. The third one is innovative advanced materials for integration of logic and other functionalities, memory, photonic communication, including graphene, TMDs, and other innovative advanced materials. And then we have innovative advanced materials for heterogeneous integration of chips and chiplets across electronics, photonics, spintronic, quantum, and other emerging technologies. And then we have innovative advanced materials for advanced interconnect to facilitate communication and power distribution between stack layers and heterogeneous components with T3 integrated chips to be used across a wide range of technologies. So chiplet integration, 2.5D, 3D integration is a very hot area. But again, we are IAM4EU will do the work that then will link up with other initiatives such as the CHIPS.JU and so on. So IAM4EU will end where CHIPS.JU start, and we will provide these new advanced materials addressing the functionalities to the market. And I close with P9, and then we move to P10, and Eva Schillinger is going to present P10 and P11.
Yes, thank you very much, Andrea. So welcome from my side to everybody as well. My name is Eva Schillinger. I am a Senior Innovation Manager at CEFIC, the European Chemical Industry Council, and I also am the Secretary of the European Technology Platform for Sustainable Chemistry, SUSCHEM, and have been a core member in this really nice journey to create this advanced materials public-private partnership. So I will be talking today about, and I think there was already also comments in the comment section on the 2 topics that we see as truly overarching that go across the 4 materials innovation markets that were identified as a first focus, but far beyond as well. So if you think back to that table that we saw before on slide 16, we really consciously decided to put the priorities 10 and 11 as such as overarching topics. So here we're really looking at a circularity aspect of advanced materials. And I don't think I need to tell this audience that polymers per se play an absolutely instrumental and crucial role in advanced materials. And that can take many different forms and shapes. So that can be in the form of structural plastics, as parts of composites, as binder matrices for coatings, sealants, just to name a couple of few examples. So here we're not necessarily looking at these polymers in combination with their final applications, but we're looking at a property that we have identified, that also you as audience have identified previously as highly transversal, and that is actually not only the recyclability, but the explicit design for recyclability. That means that here in these priorities in P10, especially, we are looking for new approaches to designing polymers with basically the thought of keeping the carbon in the loop, with the thought of disassembly, dismantling, and with the thought of creating secondary raw material sources in mind. In P10, we are not only looking at the design and of these molecules, and by the way, the sources for these molecules can be bio, can be already secondary raw material sources, etc., etc., etc. We're not only going to look at the systems themselves, but we also want to focus on new polymer recycling mechanisms, not necessarily optimization of existing ones, but we are more focusing in the direction of, for example, enzymatic or bacterial depolymerizations in this context. Now, if we're looking at the priority area 11, I think it goes without saying that this is a rather clear-cut one and at the same time an extremely complex one. We here want to focus on innovative advanced materials, especially probably in the form of polymers that are based on alternatives to PFAS. And here, of course, we all know about the necessity to replace PFAS across the markets, across the applications. However, the real challenge will be here that we are looking for solutions, and this need has been very clearly identified across all of the markets, that actually will still maintain a superior technical performance level so that the substitutes actually can be used without sacrificing any of the advanced part, basically, of an advanced material. The performance needs to come up to par and probably, ideally, even actually exceed the current standards in terms of performance, ranging basically across the markets from energy to textiles to agriculture and to health. And with that, I think we come to the close of the first section, right?
Thank you, Eva. Thanks all the panelists. I will ask Jerome to switch on his camera. So we now are going to the Q&A session. We have a few questions. There are three people, Francesco, Flora, Cor, and Virgin, with their hands raised. We will not take live questions, but please do type, and we are going to go to the questions relevant for each sessions. 48 questions were already answered by typing, and also Gemma has just launched the online survey where you can vote as a snapshot of what you think is more important. Okay, let me now go through the relevant questions. The first one is for Jerome. The comment is P3, the priority 3, can also be relevant to electronics. Can you comment on this? You're muted, Jerome.
Yes. So in terms of applications, and that's the table I've shown earlier when introducing the session 1, applications can be several. Here we are just pushing priorities on component and product perspective, addressing the materials dimension. But of course, it can be for electronics, it can be for energy for electronics, it can be energy for transport, it can be purely transport and so on. So yes, the answer is yes, it can be for electronics as well. P3.
Okay, thank you. And then we have a question for Amaya. What about new optics materials and their manufacture? The current state-of-the-art material with the biggest refractive index are, for example, not available from Europe. What is your comment on this?
So, I mean, I think anything that can be answered by innovative advanced materials, as Andrea, you pointed in your priority area, electronics means also photonics or optics. So any innovative advanced material that can provide an answer to some material that is manufactured outside Europe, ideally we would like to also cover in this new SRIA and in the partnership. Yeah.
Okay, thank you. Then another question for Jerome. Why do we need a specific priority for PMs? PMs could basically be removed as a priority, but inserted as needed in the other ones because they could be used for different priorities.
So indeed, PMs are key elements, as I said, to many different types of systems. for various applications. So they are very central. And in terms of strategic autonomy, they are an excellent example of something that is just so critical. So as such, what we think deserve a standalone or particular focus as a priority, because I've got so many applications with impacts that are actually can be envisioned at a very large scale in terms of energy efficiency. And again, it's touching directly on strategic autonomy, sovereignty.
Okay, thank you, Jerome. The next one is for Elmar Bonacorso. Are you talking about lightweight materials or materials for lightweight design?
That's a good point, but where's the difference? Is it just a semantic difference? When we at Airbus talk about lightweight materials, yes, we use them for lightweight design. Or maybe the person asking could specify.
Okay, so it's an anonymous attendee, so please do type a clarification for the question. And also there is a comment, if you have a comment on pre-preg compression molding, I assume if that is part of what we are going to cover.
Yes. It's one of the many processes that will be investigated, and yes. And here we're looking, of course, for proposals, for project proposals in this area. So anything is okay, yes.
Okay, then there is another question, Amaya. There are definitely many transversal R&I needs for several applications where semiconductors, electronic components, and systems can be found. The question said that it was not very clear in the priorities presented because semiconductors and ECS system are a huge area. So how do you address this?
So yeah, I mean, at the end, innovative advanced materials also, they are quite broad. So at the end, we are looking for new or existing materials or materials that are made in a different way that can provide different properties. So it can be as broad as needed, as long as they fulfill the function we are looking for. So in the case of semiconductors, well, we want them to be good semiconductors. Depends if we want for logic applications or whatsoever. But it is broad in general, yeah. So if you have the material and the answer, yeah, please give us some ideas also, yeah. I mean, at the end, we are looking for contributions from everybody, from industry, from research centers, academics. So yeah, all the ideas are welcome also.
We just need to stress that this is innovative advanced materials. So if we are talking about innovative application or scale up of existing semiconductor technology that is covered by the CHIPS JU. So our task is to really take completely new materials with new solution and bring them up to the point where in the future they can be used, or at the end of the development, they will be used in the semiconductor and electronics industry. So now another question for Elmar. Is priority 7 also covering mechanical metamaterials?
I would say metamaterials in general, not just mechanical, could also be acoustic, could be optical. Yes, metamaterials would be part of that. Yes, an important part.
Okay, so that's a clear answer. Then we have another question for Jérôme. In priority 3, hydrogen tanks are mentioned. Will you also consider hydrogen pipes?
I guess so, because we need to think at the overall system level. So whichever component or subpart of the system is key to ensure an overall performance has to be considered. And again, as you have seen, these priorities, they are very summarized. So they will be so developed. And yes, indeed, any subparts of a system that is deserving and requesting innovation will be considered as far as it is focusing on the IAM level.
Thank you, Jérôme. The next question is for me. So the link to AI should be made clear as the driver for materials for low-loss electronics. I totally agree. And clearly, this is a short summary. We will make sure that the text is more detailed, and this is made link because AI is the driver for massive energy consumption, and so new materials are necessary there, and also for the integration. Should analog and neuromorphic computing be called out specifically? These are also neuromorphic computing is included in one of the longer version of the SRIA as the term. I realized when I was speaking that it was missing from the slide, but it will certainly be included. And again, new materials for that. Is spintronics the right term, or should spin-based computing be more general to cover the more general case? I guess we can discuss this. If you send me an email, we can have a more detailed discussion also with Stefan Roche, who is not in the panel now, about this part based on spintronics. Then we have a question for Francesco and for Jérôme. They say no, do not use ionic liquids, but you should focus on purely inorganic salts for critical materials recovery, energy storage. Such salts can be fluorides, chlorides, nitrides. So either Francesco or Jérôme, can you address this?
Francesco first.
Yeah, we essentially the activity will be broad and will not only focus on what I present, because this is just a short test with the title, but then all the activity will be much broader, and there will be the opportunity to have also these materials included.
And on my side, just to come back to one of the guiding principles that were presented at the start, is that we are technology agnostic, we are materials agnostic. So whichever materials that will be safe and sustainable will bring the adequate solution to the problem stated will be supported.
Okay, thank you. So the next question is for Elmar. Is concerning P6 and P7. And do you think that multi-layers and nanomaterials for smart surfaces or coatings are compatible with recyclability? At the present stage, multi-materials or coatings are roadblocks for high-performance material recovery.
Currently, yes. I mean, the area is so vast, so now it's a very general answer. We can go also more into detail in here. In general, yes, but of course, we need to make them recoverable, reusable, recyclable, strippable, and be able to separate all the components. So that's the aim, and that's also why IAM4EU is here. So we need to go that way. I understand that not all coating systems, not all complex coating systems are nowadays, but that's the way we need to go.
Okay, thank you. Then we have another question for you, still for Elmar, on P6. The question or comment, and you should include in P6 not only sensors, but also biosensors, and also that the related printing techniques in jet stamping coating are quite important, and they are going to have an impact on different kinds of sensors and biosensors. The future of innovative advanced materials application in sensors and biosensors is going towards the deployment of unique properties that solve real problems with clear advantages beyond the state of the art. It is very important to keep this in mind, otherwise the impact will not be achieved. Do you want to comment on this?
Yes, I mean, the author said it all in the second part of his question. Sensors for me cover also biosensors, but again, here the question is, it doesn't mean biosensors in the sense sensors that sense biomolecules or sensors based on bio whatever receptors and so on. Nevertheless, they are part of it. I agree with the manufacturing techniques. It's part of that. But one thing is, there was also another question related to biomedical applications, biomedicine, and so on. So if we go in that area, this is not contained in IAM4EU, but there, Jerome or you, Andrea, maybe can comment on this as well. So there's a distinction that we need to make at some point. So what goes into IAM4EU and what goes to another partnership?
Yeah, so IAM4EU is not dealing directly with health and biomedical technology at the moment, but the development of new materials for sensing, that is included. But maybe we cover this in the second part of the priority discussion that are more on the policy levels.
Yeah, but maybe that's the right time and opportunity to send out this message that indeed we are coming as a new partnership inside the landscape, which is already full of partnerships, being sectorial or transversal, and we won't be a new standalone initiative. We are to connect tightly with those in place and to find the right synergies to maximize the impacts all together. And for instance, and just to give an example, we have been discussing with colleagues from the Clean Hydrogen Partnership, and we have found quite a nice way to collaborate in the sense that, for instance, on innovative advanced materials, IAM4EU would be well positioned to work on the first segment of the value chain at designing, developing, and producing new materials, innovative advanced materials, but also considering their recovery and recycling, while clean hydrogen is more focusing on the processing of IAMs, on the transformation of IAMs into components and their assembly into systems, and then the demonstration, the upscaling. So that's an example where we can find a nice synergy, be complementary, but also be additional in terms of support between two partnerships. So that's the type of synergy we will be looking at with each relevant partnership, and these synergies will be different in each case. And also just another minute to say that, for instance, if you take process for planet and made in Europe, and also raw materials partnership, all these partnerships are absolutely key for us to collaborate with. And of course, we will implement processes and manufacturing equipment and methods that are being developed by these other partnerships. We won't support them, we won't develop them as such, but we will implement the most updated solutions they are bringing to us. But whenever there will be no solutions available on the processing side, on the manufacturing side, to design and produce new materials, and then we will be in a position, IAM4EU, to support the designing and developing of these processes and manufacturing. So you see there are different ways to envision the complementarities and the synergies. And that's what we are working on at the moment. Thank you, and sorry for being long.
Yeah, thank you, Jerome. The next one is for me, but also for Amaya. Does Priority 9 cover advanced patterning materials needed by the European semiconductor industry? So my answer is, insofar there is an innovation in the material, for sure this is covered by Priority 9, but also by Priority 8, because new innovative advanced materials for patterning could also be reducing some of the critical material used. I don't know if Amaya, you want to add something on this?
No, I totally agree. So any innovative advanced material that also contributes towards the twin and digital transition, yeah, is more than welcome. Yeah.
Then another question for me, under the electronic strategic area, there are missing materials to add functionality at back end of line in advanced computing system for materials for non-volatile memories, which have application in neuromorphic computing. As I said, yes, indeed, the word neuromorphic was missed out, but it is present in the long version of the SRIA document, and this will be rectified. Neuromorphic computing and relative materials are definitely included. I mean, materials for neuromorphic computing, including in back end of line, are included in the priority 9 and also priority 8. Then another question for Elmar. can you give some comments on innovative joining technologies? Because you need to join different parts together. And I would say also disjoin, because there is the opposite as well.
Yes, I was just answering this now in a written form. A brief comment, yes, there will be part of it also, probably in one of the next calls as well. Very important, in order to be able to assemble and disassemble, so for recycling and reuse of the materials, of the components, these are very critical materials, and we need to have the right processes associated to it. So joining, which is a reversible joining, yes. So they will be part of it.
Okay, so I will not cover questions that will be covered by the next sessions, but I will go to the next one that is relevant for this session. So where is innovative advanced materials for advanced packaging for electronics? Packaging is covered in P9, but also in P8. So definitely advanced packaging is absolutely crucial, and new materials for advanced packaging will be definitely developed. But this is different, again, from what is done in CHIPS-JU, where there is an advanced packaging pilot line. So we need to develop here the new innovative advanced materials up to the point where they can be taken up by foundries later on. I will go to the next one for P2. Jérôme, does P2 only cover membranes or also other materials for hydrogen production, such as photoelectrodes for photocatalytic water splitting?
Yeah, yes, they do. And actually, we have not been fully comprehensive in the writing of certain of these priorities, and they will be further substantiated, but the response is clearly yes. Any essential component of the system will be considered.
Okay, and then a question for both Francesco and Jérôme. Is the direct use of renewable energy in the manufacture of IAMs included in this initiative? Let's Jérôme and Francesco.
Francesco, you want to start?
Yes, I do think yes. In my view, it can be included.
And for Jérôme?
So I don't want, in fact, this is a point we discussed some time ago with P4P and Made in Europe as well. This topic is in between somehow, but this is a topic we see more on their side than on our side. But Francesco, this is still open to discussion.
Yeah.
But whatever energy you can save, energy efficiency in the processing and in the manufacturing and so on, this is more on their side than on our side. That's my understanding, huh?
Yes, I tend to agree with Jérôme. Insofar you are developing some innovative advanced materials to use renewable energy, this will be included, but as a direct way in which it was questioned, most likely not, but we are happy to, why don't you send us an email directly so we can have a discussion after the meeting. Again, for P7, so for Elmar, you mentioned that microstructure optimization of metals is within the scope, but it is not reflected in the title. Is alloy development and new thermal mechanical properties of metals within the scope?
Yes, there's a glitch. I also realized that metals is not included, so there's only composites. But yes, we are also focusing on metals and alloys development, yes.
Okay, I will then give the next one to Eva. Is there any focus in the decentralization of manufacturing with waste materials, thanks to digital manufacturing and local recollection of ingredients, instead of the massive central production to avoid transport cost? And this is relevant for P10, but also to P7, but I will ask Eva to address both parts.
Yes, and I already gave that some thought, and I do believe that this is actually a topic that fits even better with a priority that is to follow, I believe, in section 3, if I'm not completely mistaken, where we also talk about circular business models. Of course, it is to be seen very much in combination with, for example, the new recycling technologies that we're addressing. But I would say that this is not a purely technical topic, but this for sure also touches very much on the circular business model side. So it has a home, maybe not necessarily directly under P10, or if combined with a new technology, of course, this will then depend on the structures of the calls.
Thank you. And then the next question is for me. Are metamaterials for antennas covered in P9? Yes, this will be covered in P9, and this will be made more clear in the long version of the SRIA. Then the other question also for me, semiconductors are not only for logics, but also for consumer market, energy, and so on. Yes, this will be included again insofar you develop new innovative advanced materials, for example, for power electronics. And this links to the next question also for me. The high voltage wide bandgap semiconductors for packaging on power electronics fit within the scope. They will fit within the scope if there is an innovative element. So if you're just using silicon carbide for automotive without any innovation, this will not fit with the scope, but it fits 100% in the scope, for example, of the new wide bandgap pilot line funded by CHIPS-JU. So if you are developing a really new wide bandgap semiconductor, or you're using an existing one for a really new application, this will be part of the scope, and that how will be distinguished. The next question, I will give it to Elmar again. Will low carbon material for construction will be considered? So formulation of low carbon cement, clays, geopolymers, and activated minerals. Maybe also Jerome wants to comment on this.
Yes, they come a bit short right now, but they must also be integrated, exactly. So it could be also P7, exactly. So just work in progress. But Jerome, please also.
No, there's nothing to add on this one. No.
Okay.
So consider it as a P7, yes.
Okay, perfect. And I think this one is also for you, for environmental sensors to be spread in the field. For example, environmental monitoring or agriculture, compostable electronics is essential. Which priority is covering this? Well, maybe I can cover it. It's clearly cross priority because it's part of the electronics part and also on the sensors part. But clearly, compostable electronics is a very interesting topic, and we must make sure to. I don't think the word is mentioned at the moment in the SRIA, and I will definitely we should definitely consider adding this one. So another question for Jerome: does P3 also include materials for innovative ways to compress hydrogen, such as absorption, desorption compressors?
I'm sorry to come back to the same answer I made earlier, is that again, any solution that is bringing something in terms of energy efficiency, in terms of energy functionality, that is depending on advanced materials innovation will be addressed. And again, these priorities, they are not fully comprehensively written, described, but the envelope is larger than the simple text we have presented you. So yes.
Thank you. I see many hands raised. Again, we will not be able to let attendees speak, but do please type the questions and we will go through the question. The next one again for Elmar. What about waste-based ingredients for 3D printers, for 3D printing with bioagglutinants?
Okay, I was also answering this now by texting. I'm not so sure I understood. So this seems to be a very specific request, bio-based agglutinants for 3D printing. It was not, yeah, it seems to be fitting also in P7, but maybe we need to have a discussion on this, because to me, this is something new, I admit.
I just add the same comment. We need to go back to the definition. Insofar, it is a development of a new innovative material or an existing material used in a completely new way, that will be covered, but of course not the use of the scale up of an already existing material or something like that. So, but sure, we need to consider this part.
Yeah.
And we will take
so maybe get back to us, maybe writing an email or so,
Yes.
and exactly those, to be able to understand the need.
So then a general question, multi-materials or hybrid materials, especially metallic, non-metallic materials, are covered by several of the priorities, and the answer is yes. So clearly, the priorities are covered in teams, and you can see surfaces, energy, and so on, but not specific materials apart from the permanent magnets. So it is clear that multi-materials can be used from electronics to composites and so on. So this will be part of the different part. So the upscaling of the IAMs will be directly covered from us or from other initiatives. I think the answer is potentially both, because if you have a completely new material that you develop from zero, from first principle, then we will definitely need to upscale it. But if it's already a well-established material that you only need to upscale, that potentially could be covered by other partnership. I think we will get back to this question more in details later on. So the question for Jérôme, developing catalyst using high throughput approaches has been mentioned in priority 1. Is using self-driving or high throughput approaches also contemplated in other priorities?
Yeah, so before answering this question, just to say, Andreas, that we have the results of the poll. So it could be nice also to share these results with all the participants before closing the session. So I would just want to send out this message.
Yeah, Jérôme, I think we will show the 3 results after the break and use them as the starting point for our discussion. So we give a little bit more time to people to
Yeah, but these results are specific to session 1, so it's better to show them in session 1, and then we'll have another survey for session 2, and so on. So again, it's better to open the results and discuss them just by closing this session. So sorry for this comment. This was our first session, so we are still warming up.
Okay. Thank you, Jérôme. So maybe we can have a look at the results at the moment.
And the answer very shortly to the question was that for catalyst, but it is true also for mostly all the innovative advanced materials we are expecting to develop through the other priorities, is that we want to implement digital technologies. We want to implement these maps, these materials acceleration platforms with automated systems, so to be able to explore the materials space more efficiently and much more quickly. So
this comes in section 3. This comes in section 3.
And this comes in section 3. Thank you, Peter. So yes, Andrea, all yours.
Yeah, so I just want to cover one specific question on electronics. If the development of IAMs is excluded from the CHIPS JU or can be done in both programs, I think the borderline between the two is the following. If you develop a completely new material from zero up to the point where it can be demonstrated, this is mostly IAM4EU. If a new material has been developed and now it is ready for deployment in large area electronics, this is done and can be done within the CHIPS JU. And I know about specific examples of the two. And clearly, it's not like there is an overlap at the top of the IAM4EU and at the bottom of CHIPS JU when it comes to innovative advanced material, but it's a small overlap. We don't fully overlap. So you need to see it across the development. So we have now received the initial survey. I didn't have time to look at it, so maybe Jérôme, you can comment because I was chairing the session.
Yes, so you can all see this horizontal Pareto. So what to say is firstly that all 11 priorities seems to be relevant and have raising some interest across the audience. Of course, we have min and max, but I would say that they are mostly all relevant. And then we see out of the hat some top priorities, being the ones on surfaces and interfaces, the one on lightweight, and also the ones on polymers, polymeric composites. So these three seems to make the top three. And we have and also P3, the one on concept and design for storages. So that's about the priorities, bearing in mind that we have 257 voters, and while we have an attendee of around 400 people, so not everybody voted. So please feel free to, I know it's closed now. And then if we look at the sectors of applications, quite a nice result. We see again that we are all interested by these four areas, sectors, but it also goes beyond. There are other sectors we know and that we have mentioned that are of interest for this initiative. So this is confirming that these priority areas are highly relevant. And finally, the last question, and which is also an important one, we see that a majority of the voters do foresee private investment, meaning investment from their own company or own organization, in-kind investment on the topic. And this is very good news because this is part of the game. You know, this is a public-private partnership, and we are expecting the private side also to invest complementarily to the public side with Horizon Europe. So that's it for me. If you want to add something, Andrea, otherwise you can close.
No, thank you, Jérôme. I think it would be good if we keep the surveys open until the end anyway, because there are half of the people we did not respond, so they may want to do it later on.
So
and
just
now
excuse me on this point, just to clarify this point, the session is actually closed, but the offline surveys that we will launch after session 3, people will be asked the same questions, but with more details. So the information will be captured again. Okay.
Yes, thank you. So we are in perfect timing, actually only 1 minute late, and we now need to move to section 2, and this will be on cross-enabling tools and methodologies. And I will hand over, I think, to Christian as the moderator of this session. Christian, please go ahead.
Thank you very much, Andrea. Good morning from my side. My name is Christian Seitz. I'm with BASF, and as such, I'm part of the core team for the preparation of the partnership. It's my pleasure to guide you through the second session, cross-enabling tools and methodologies, after we have been discussing the more, let's say, these technological items and topics. We would now go to consideration of topics that go in the, let's say, overarching consideration of the innovative advanced materials value chain and also in the circles. This session deals with digitalization, making knowledge and data available along the whole value chain. And we picked and elaborated on 4 priorities for research and innovation in that section. And I would like to bring Peter Klein here on stage. Peter is a senior researcher with the Fraunhofer ITWM in Kaiserslautern, Germany. Stage is yours for P12 and P13, Peter.
Yes, thank you, Christian. Thank you very much. So I'm going to present a team effort on defining priorities in the area of fair and semantic interoperable materials data spaces. And in the materials modeling, characterization, and testing area. Of course, both are related to each other, as you will see in a minute. We start with priority 12, which is more on the integration or integrative frameworks along value-added chains and including circularity. And what does it mean for materials to pass over from, from raw materials over materials production to processing towards products, product lifetime, and towards the end of life. So we have here the overarching framework, which is more or less handled in priority 12. And the specific tools needed in order to make everything happen, this is more in priority 13. So we start with 12. Here we are talking about a fair and semantic interoperable digital materials data space. This closely relates to the materials commons infrastructure on the one hand, which had been announced in the policy communication on the advanced materials in February of this year. It should be a means to integrate safe and sustainable by design considerations along value chains. So whenever things show up which are related to more than one stage in a production chain, which goes into the SSPD part, then this should be there. We have the ESPR, which is talking about, in the end, so the Eco Design for Sustainable Product Regulation. So probably SSPD could be considered as a kind of a precursor to delegated acts under the ESPR. So we need to talk about how to integrate things along production chains in order to come up with the envisioned digital product passports at the end, as defined by the ESPR. So this sets a little bit the frame of the next priorities of the next two. So what we need here really is to implement a digital infrastructure which is equipped with standards, which is equipped with fair principles, which is equipped with, in the end, even with widely usable and shareable metadata that could be used by many different people for many different purposes. We want to enhance the data usability and we want to maximize the value along value chains by intelligent and context-aware interfaces to this digital framework. Of course, on top of all these and pretty modern, we have AI and ML technologies, which should enable really to quickly find, analyze, and exploit data which are produced along value chains. Think in terms of recycling, just as an example. It makes an awful lot of sense that the recycler knows how the material got processed and how its use phase went when it comes to recycling. And those data can be analyzed, of course, using AI and ML technologies. To this end, we need a federated data governance model. We need to enable collaborative by design processes and in the end, even digital product passports, because they are going to get enforced in the end by regulation, simply. So, of course, we want to do this from a materials end, and in between there is production, and we need to collaborate with, for example, manufacturer and others in order to make this happen, in order to bring the materials, the innovative advanced materials through these kind of frameworks towards manufacturing and towards all those things which are necessary to fulfill regulations, even from this end. So this is about the more or less the materials commons and how we envision it, and probably integration of EOSC and the national initiatives in this area, which are already ongoing, like the Platform Material Digital and DRM in France, big map approaches. But in the end, we need servers. In the end, we need a hardware infrastructure in order to make this happen and in order to make these things sustainable. So this brings me to the next part, to priority 13. Can I have the next slide, please? So these are the priorities for the materials modeling, characterization, and testing, which should feed these materials commons infrastructure in the end, and in order to make things really circular, really along value chains, really for the integration of all actors. So to this end, we need, of course, reliable and in-depth performance prediction models for the functional properties of all these things. They need to be interoperable because materials usually tend to be important on many different scales, from the atomistic up to macroscopic scales, and we need to be able to integrate these things. So we need to develop multi-physics and multi-scale modeling frameworks together with the simulation and characterization methods. And these should be tools. These should be really tools which produce in the end data. These data go into the materials commons data spaces, and then they can get utilized. We want to develop digital twins covering really the full life cycle of IAMs from the production of the material up to the recycling, including use phase, manufacturing stages, modifications during manufacturing steps, all these things. We want to support reference materials data, which give you a means of judging on what you have in the field when materials are in products and in the use phase. So the idea is, if you have these kind of reference, you can compare actual states towards this reference and go for predictive maintenance and all these things in the use phase. Predictive maintenance, repair and overhaul. And this should be backed by materials reference data, which should be open and which should be available on the materials commons, or probably on EOS, on the European Open Science Cloud. This supports the monitoring methodologies along the entire materials life cycle. Their result goes into the data spaces as compared to reference data. This is the idea, and to this end, we need the appropriate sensor technology as well. We want to promote statistics and data science tools, which gives all actors along the value chains really the idea how to use these data and how to use them, for example, in design of experiment approaches towards the development of new innovative advanced materials, which are then context aware, and the context includes then the whole value chain, even up to recycling. This is one idea here. If you want to leverage AI and LML modeling tools to use data analysis, this is a modern thing. We will see how far we can get with this. And in the end, even try to automate the discovery of new materials by utilizing these AI modeling tools. And to this end, in particular at this end, it is probably going to be important to have the data spaces annotated by ontologies, because this would enable a technology, an AI technology, which is called reasoners. And this means a reasoner has the ability to transform knowledge from one context to another context. And this context is a materials value chain, for example. So at least at this point, ontologies are going to get important in this game.
Peter, if I may ask you to come to an end, please.
Yeah. Okay.
Sorry. Yeah. I have to
2 points.
Keep a little bit on the time.
2 points. Along the way, we need correlation of materials properties and performances. I mean, this is more on a standard. what is probably new is we want to implement feedback loops from the use phase and the end of life to design into the development cycle of the IAMs. And that's it from my side. Thanks.
Thank you very much for presenting these two priorities. And for the priority number 14, validated test methods supporting the implementation of safe and sustainable by design, I would like to bring Alberto Bianco on stage.
Good morning, everybody. I'm Alberto Bianco. I'm Research Director at CNRS in France, in Strasbourg. So this is a priority that is dealing with the implementation of safe and sustainability by design. There was a question in the previous section related to this, so it comes now. The idea here is to implement SSBD from an experimental and a theoretical point of view, and this needs to respond to the recommendation that has been set a couple of years ago by European Commission on implementing such SSBD in the development of material and chemicals, and this should apply to the advanced, innovative advanced material. So there is one part that is dealing with test methods, somehow to prove that these methods are applicable to innovative advanced material, and this is necessary to provide information on human and environmental safety, on sustainability, and this all along the entire value chain and the life cycle circularity, in order to assess the impact on the environmental and society. And this should be in strong relations with the techno-economic performances of functionality and durability of such material. We need also to reduce the need of animal experiment, and so this will somehow allow to go through development of predictive safety models that are strongly needed, and this model falls into the more general umbrella of new approach methodologies to assess specific question about safety and sustainability of innovative advanced material. And this should assist the research and innovation phases. And in terms of new approach methodology, we can think about in vitro testing, while for predictive safety models, we will should go to in silico application. And then the second part, developing inverse and forward material models, this is as a sort of overlapping with the priority 13 that has been already introduced by Peter, and so this computational methods are really to automatize the process of designing material with required performances, and at the same time in a forward approach is to somehow to predict and simulate structural changes or functional changes or functional evolution in order to predict efficiently how to maintain somehow and change the functionalities and the characteristics of this innovative advanced material. And with this, I will stop here.
Thank you very much, Alberto, for your lovely presentation. With that, I would seamlessly jump over to priority number 15, data management and curation for efficient SSBD. This priority will be presented by Natalia Kontrakova. She works with the Helmholtz Center for Helmholtz Center Herion in Germany, Geesthacht, and she's also coordinator of the DigiPass EU project.
Thanks a lot, Christian, for a kind introduction. I would like to speak about safe and sustainable by design framework and the development of this framework to better social decision-making process in the initial stage of discovery of materials and development of materials. And this framework now under development, all of us know it is very important process, and Alberto already mentioned it was here request by Commission, and currently we are focusing on the safe and sustainable by design concept for advanced materials, innovative advanced materials development. Informed decision-making of innovative advanced materials development request, of course, interconnected data and in correlation data and software modeling tools for effective prediction of materials behavior and effective using the collecting data and reusing of data. Of course, combination of safe and sustainable by design tools and classical different modeling technologies and software will support the smart use of data and efficient of using and integration of safe and sustainable by design principles for industry and industrial workflows. How to implement it and which priorities we are thinking to implement for this safe and sustainable by design aspects. It is data management and creation for efficient SSPD. First of all, it is semantically integrated safety and sustainability into the materials digital ecosystem. It include, of course, the further development of semantic tools, and we heard already from Peter importance of ontologies and these correlations of data and semantic description of data. And if we are speaking about safe and sustainable by design principles, we need to take into account not only physically tested data, but recommendations and medically, biologically investigations and requests, and all this data needed to be prepared in semantically form, extending, mapping, and integrated in complementary existing ontologies. One time more, it is the data which are corresponding for physical testing data and digital storage data, and this aspect is currently missing. The next aspect, it is linking existing life cycle assessment and safe and sustainable by design modeling and simulation tools to materials digital ecosystem, where you heard about eco design for sustainable product regulations, documentations, and general frame of eco design of new materials, including advanced materials ecosystem. We're focusing on the development of new innovative integrated workflow using data-driven and artificial intelligence approaches and physics-based modeling approaches to assess safe and sustainable by design criteria and LCR scenarios for advanced materials, innovative advanced materials, and to reuse materials modeling, characterizations, and characterizations tools and achievements for optimization of functionality of materials and development process of advanced materials. And the last point, it is the work on the new standardization standards for documentations of LCA and Safe and Sustainable by Design data to bring this data to be reusable and for digital ecosystem and follow the FAIR digital principle, FAIR data for data management principles for materials commons and support these approaches. For example, we need to follow, for example, for metadata requirements of Organization for Economic Cooperation and Development, harmonized template and other documentations, and bring this, make this data management and interoperability of data as a center point to give the accessibility of all achievements from SSBD and life cycle assessment for new materials, innovative advanced materials. Thanks a lot for your attention.
Thank you, Natalia, for presenting that. We have now the 4 priorities that are dealing with the cross-enabling tools, and we received a couple of questions related to these priorities. I would limit the number of questions a little bit and start with one question directed to Peter. How will the strong EU community involved in the foundation AI models will connect with the future federated infrastructure materials commons?
Yeah, that's a good question. Probably at this point a little bit hard to answer because the materials commons infrastructure is still a kind of an elephant in the room. So it is not graved in stone on how this is going to look like. But what we can expect is that there is a kind of a federation, kind of national hubs, national regional hubs, which are going to implement according to certain standards, which are compliant to regulations, the materials data harvesting, say it this way, which allows for, say, local smart specialization towards local environmental things, about local economic, socioeconomic integration, but an overarching kind of layer is there, which is more or less standardized across Europe. So this is how we believe this is going to be. And if the materials comes is open, which is not on us to decide. Yeah? If it is open, then it can be used by AI tools, of course. And all the data which are on this open space can get used in AI modeling.
Okay, thank you very much.
Hope this answers the question.
I hope so too. Okay, then another question is going to Alberto. Is the development of test benches and material testing infrastructure contemplated in priority number 14?
Yeah, I think here there are two points. One is test benches, I think that we contemplated somehow to apply the test guideline from, for example, from OECD and see if the innovative advanced material are somehow can be tested using the current guideline and eventually validate them or propose modification. Of course, there is to me a room for new development of new tests. Then how these tests are recognized for validating and the innovative advanced material is another point. And then in terms of infrastructure, I think it's important because there are some materials that are very difficult to detect in an environmental or in a biological environment, and so it is important to me to have new tools, new analytics, for example.
Thank you very much for your answer. Another question is going again to Peter. You mentioned hardware, servers, etc. Who will be responsible for the hardware infrastructure required for the materials data space, IA, finance, support, maintenance?
Yeah, that's a very good question. And this is still, as far as I can say, not decided yet. The materials commons infrastructure got announced in this policy.com from February this year, where the Advanced Materials Initiative got announced as well. So, to the best of my knowledge, a governance structure and the business and the kind of a business model behind the materials commons infrastructure is not yet fully defined.
Mm-hmm.
That's all what I can say. But it's what I can say as well is probably that it is not on the agenda of IAM4I to set this up, because we are usually not covering the capex of infrastructures within this partnership. So here we need to rely on what comes on the table from the outside, from the European Commission, from member states, from how they agree on that.
Okay. However, thank you very much for this hint. Another question on circularity and biodegradability, and the link to session 1, the more technological questions. There is a question. Sorry, this is.
Maybe I can start to answer the question. Yeah, Christian, if you it is circularity and biodegradability.
You saw the question, but
I
for
can
the
see
other
it
in the audience, would it not be important to have also cross-enabling activities in these areas? They are partly covered in SSBD, but I think they go beyond what is in the SSBD EU recommendation.
Thanks a lot for the question. Really very interesting to see this cross-enabling activities and relevancy of the topics. And circularity of materials was already mentioned, I think that's in the beginning of the session. And of course, it is reflected to safe and sustainable by design aspects. Should be mentioned and should be considered. And this specific biodegradable, I think that's the Elmar already answer in previous part. It is really a very specific question. Please address it separately. But in general, yes, thanks a lot for mention these aspects. It is cross-industrial, cross-sectoral, and of course it is relevant for many materials, advanced materials. Thank you.
Mm-hmm.
If I can add on the biodegradability, is this part of the assessment of the safety. So it is definitely an important point to address.
Yes. Yeah. Thanks a lot for question.
Okay, thank you, Christian, for this session. Maybe you can show the result of the survey before we move to the next one.
It's not in my power, Andrea, but Jeremiah, if I may ask you, are there any final results on the survey? Thank you.
Yes, okay, now it's on the screen.
Yeah,
you want to comment?
Yes, for sure. I see we have quite relevant topics here for all the 4 priorities, with a slight preference for predicting life cycle of materials. So that's clearly a focus area to consider the full lifetime circle, and it is, let's say, it's a DNA of the IAM4EU partnership to widen the scope a little bit from the linear value chains to look into a more circular thing. Anyway, the results will be available, and with a view to the time, I will get back to Andrea. Thank you.
Thank you, and thank you. Thanks all the panelists of this session. We move to session 3, which is ecosystem enablers and synergies. And this session will be chaired by Peter Klein. And again, a reminder to the panelists to stay within the 4 minutes. Peter, please go ahead.
Thank you, Andrea. In session 3, we are talking about an even wider integration say along the technology chain. We're talking about business models there. We are talking about how to integrate even more stakeholders into the development of innovative advanced materials, and about synergies towards the Advanced Materials Academy, towards how to integrate existing infrastructure like large research infrastructure and others into the materials integration, into the materials development. And this ends up with a priority on contributions on standards and norms, because in the end they set the scene, as I already mentioned in my presentation. According to the Eco-Design of Sustainable Product Regulation, we will face these things in the near future. So with this, I will like to ask Francesco Benacuso to present priority number 16 on new business models which are based on IAMs.
Okay,
Francesco.
thank you, Peter. I will try to be quick. So, for what concerns the first point, it is clear that Europe needs a supportive business environment and also a skilled workforce, mostly in the area that are crucial for the green and digital transition. And in this aspect, essentially, the market expansion and the diversification is key. New stakeholders need to come into the play, and they can help expanding and diversifying the market. In fact, their involvement can bring to the identification of new application area or defining more niche application. The diversification expansion can drive economic growth, create new business opportunity, and increase the overall exploitation of innovative advanced materials. IAM4EU essentially require that both innovative advanced material development infrastructure and data infrastructure will be exploited. And although the research infrastructure will be also relevant, the technology infrastructure will be the focus of IAM4EU, essentially due to their involvement and role in the development of innovative advanced materials. And this will be also important for the involvement of industry, and in particular case, small, medium enterprise and startup. Another key point that you discuss in your priority number 12 is the development of a federated data governance model, but you already discussed. Also, for what concerns the safe, sustainable by design, the research innovation priority on innovative advanced materials share common requirements to align essentially the principle of safe and sustainable by design and circularity. It is crucial to address safety and the sustainability of innovative advanced materials. It is crucial to secure the integration of safe, sustainable by materials from the innovation process till the market. And this, in one sense, will accelerate the innovation cycle of materials by considering the entire life cycle. Last but not least, for what concerns the end of life of innovative advanced materials, this is a critical point for all the materials, in particular for innovative advanced materials. It is clear that there is a need for a radical change in this concept. to exploit at best the materials from the development to the integration into the product, and then until the end of life and reuse and recyclability of the materials. In this concept, in this context, it is important to develop integrated feedback loops that support the innovation material that will improve the overall sustainability and circularity. All this will bring essentially to enhance the material optimization and the circularity in an overall way. I'm done.
Okay, thank you, Francesco. So we've heard about the new business models, and but what we want to, the overarching point is how to integrate more stakeholders, and this is probably a little bit answered in priority 17, and I would like to invite Christian Seitz on the stage to present priority number 17.
Thank you very much, Peter. As you quite recently said, we have a much broader, let's say, a stakeholder community to manage with the occurrence on when we want to implement circular business principles, and that goes far beyond the existing stakeholders, in which they have their, let's say, their focus on certain stages of the innovation chain. The main idea of this priority augment by an incentive system is to have a system to motivate these new stakeholders to get involved into the research and innovation processes for the innovative advanced materials. So it's not only the developers of these materials, the manufacturer of these materials, and the downstream users, but also regulators, the broad public, if they might be included in these discussions. And to bring them all together, we have a couple of, let's say, platforms dealing with specific questions. We come to that in a minute for standards and norms. We have that for regulatory aspects. And the idea is here to have a kind of overarching system that supports the whole innovation process with the primate of collaboration along the value chain. Thank you very much.
Thank you, Christian. And with this, we come to the next priority. Of course, we need to equip the European workforce with the necessary skills, and this is what the synergy with the Advanced Materials Academy, the priority 18, is all about. And I would like to invite Andrea Ferrari to present this.
Thank you very much, Peter. Yes, in the Advanced Materials for Industrial Leadership announcement of the Commission, there was the announcement of the creation of an Advanced Materials Academy. And of course, as IAM4EU, and especially as IMI, Innovative Advanced Material Initiative, we will need to work closely and directly with them in order to co-develop some of the training activity. So we envisage a coordination activity involving the relevant third-party stakeholders from research, industry, institution in general, regional, national, and European levels. Our task will be to identify the education and skills needs. What are the needs that are the skills that are needed in Europe in order to ensure the success of new innovative advanced materials? So, and how do we incorporate in a training program that can be addressed broadly throughout the Union? For example, including topics such as SSBD and digitalization that often are not covered at the undergraduate level. We also need to consider training more generally and upskilling and reskilling. So we need to consider what are the training offers already present, identify the already available training programs and how this can be integrated. And also, as I mentioned before, most importantly of all, in interaction with industry and the different stakeholders, what are the gaps? where do we need to invest for training in Europe so that we can have the future workforce for implementation of innovative advanced materials. Thank you.
Thank you, Andrea. Our next priority in this session goes towards networking and widespread use of technology infrastructures. And I would like to invite Amaya Zurutuza to present this priority.
Yes, priority 19 is related to networking and promoting the widespread use of TIs or technology infrastructures. And we have two objectives here. One is to bring together key stakeholders from research, industry, but also institutions at regional, national, and European level, at the end with the objective to map and assess what is available, right, in terms of TIs and also the access policies related to those technology infrastructures. And at the end, we want to coordinate a network of cross-border infrastructures and services. And the idea is first to map them, identify them, and then connect them, let's say, offer these TIs to industry, to whoever wants to access them, basically at the end to offer them to the relevant stakeholders in Europe. And with this, we want to promote excellence of innovative advanced materials across Europe, right? And we would like to do this with a single entry point. So everybody can go to a website, or I mean, it has not been defined yet, but to a single entry point where they can visualize what is available, and in order to share results and connect with relevant stakeholders. And at the end, we want to have an inclusive ecosystem in order to provide this test before invest services to everybody that would like to use them. And the second objective is related to promoting the use of existing TIs by encouraging their integration into different actions, like it can be CSAs or research and innovation or innovation actions. And all this, of course, related to the research and innovation of innovative advanced materials, but also associated technologies and cross-enabling technologies. And what the IAM4EU partnership will do is to incentivize projects to leverage existing TIs and foster let's say, the collaboration and formation of consortia in order to use the existing technology infrastructures and put them in contact with interested end users. And yeah, at the end, this approach will be coupled with a strong commitment in order to have, let's say, effective communication and widespread dissemination of these TIs in order, for SMEs, large companies to know what's available out there and if they're interested to try to use them. Yeah, that's it.
Thank you, Amaya. The next priority in this session is going to get presented by Natalia Konchakova. This is not unrelated to priority number 19, because priority number 20 deals with already existing and running, more or less, infrastructures and how to integrate them fast in order to accelerate really now from the very beginning. So Natalia, please.
Thank you very much, Peter. Yes, we're speaking about different infrastructures, including both physical infrastructures and digital one. And we're speaking about technology infrastructures, which will help to accelerate development of materials, innovative advanced materials. And we're speaking about involvement of industry, particular SMEs and startups to using these infrastructures and to contribute to this to infrastructures. About which infrastructures I'm speaking now? It is large research infrastructures, first like electron synchrotron or neutron-based facilities, which supporting technology transfer and development of new materials, which providing the specific unique technique to characterization and testing of materials, and to which support acceleration of innovative advanced materials life cycle investigation, and looking for the characterization of materials for their whole value chain. Next infrastructure is open innovation test beds, and we are speaking about physical facilities or digital facilities. It is some pilot line or platforms, and these facilities requires to accelerate the development, materials development, and using and customization of technologies developed from in the frame of H2020 projects or some Horizon Europe projects, funding currently by Commission, but we would like to bring and enforce this accelerating testing and scaling up of technologies and integration these technologies in their product line. And the next, it is materials acceleration platforms and self-driving labs as technology infrastructures, which is the key element for acceleration testing, which based on the robotics concepts and using the artificial intelligence and design of experiments methods for data analysis, for data acquisition, and these technologies reduce the number of manual experiments. Of course, it is accelerates the time to market and accelerate the testing process at least 10 times faster as standard process. And maps, of course, include some software and modeling approaches, and provide structured semantic data spaces and deliver the data in machine readable form. That is why it is the technology which we would like develop and concentrate on this type of technology as well. This domain-specific data spaces delivered by large infrastructure. For example, you know, there's the after synchrotron measurements, you have a lot of data. After open innovation test beds and using platforms, you have the other data and maps as well. All this infrastructure can contribute for digital infrastructures and for federated materials data space, which was mentioned in previous session, for cross-sectoral data exchange, and could contribute for materials common concept as well, and support safe and sustainable by design concept as well. Good. Which priorities with steps which focus for this aspect we have? First of all, accelerate to use of this technology infrastructures, identifications of low-hanging fruits, so accelerate the research cycle. To use these automotive experimentals and lab facilities, simulations and artificial intelligence, data analysis and optimization criteria for new materials design. The next point, it is make lab scale automation by open hardware and with the open source drivers and protocols for lab instruments. The next aspect, it is correlated with the data space. Of course, it is data as software interoperability. This cross-industrial linking data schemas utilizing the cross-linking ontologies for processing and materials characterization data and tools. And this brought accessibility of software and hardware, and to give the possibility to researcher, it is academic researcher or industrial researcher, to access this infrastructure remotely. Thanks a lot.
Thank you, Natalia. Thank you, Natalia, for this presentation. And in the end, the last priority in this session is about norms and their development, because this is going to be important once we strive for industrial leadership, which means in the end market entry, and market entry is always accompanied by norms and standards. So I would like to invite Christian Seitz on the stage to develop this priority.
Thank you very much. And also for the introduction into this topic, which is, I guess, a very predominant and a very important pillar for the acceleration of the innovative materials development that we strive for. It's one of the main targets for the initiative. And if we consider or have in mind that a new materials development on average takes 10 years, and in parallel, that's questionable, 6 years for the approval of a new material, including all these development of test guidelines for real new materials, then we have to consider that as early as possible in the innovation process. Therefore, we question how can we implement that in the partnership and in the research priorities if we want to keep that whole thing handleable. We would like to propose that at least we could, in the innovation processes, in the calls, in the projects that are running in the, let's say, fuzzy front end of innovation, where hopefully a lot of new materials will come up in the future, we could implement a stop where we identify gaps for standards or for test guidelines that are not existing yet or are not applicable. We could rely on the experiences from the nano safety community here, from the Malta initiative, where we got a lot of input for that, and also discussing what is doable, what is achievable in the course of the Advanced Material Partnership. That is what we came up. We could contribute to these test guidelines when we discuss and define where are the gaps and what are the needs for the materials. So let's say a mean for early regulatory involvement and regulatory preparedness. That would cover, of course, harmonized criteria on the guidance of testing circularity by the biodegradable in the SSBD framework. That would cover also harmonized test methods for standardization processes in close collaboration with OECD. And it would also cover harmonized quality assessment and quality control procedures for multi-component systems, for instance. But it would also cover the standardization of LCA standards, which are today not really on top to be implemented in the innovation processes. There's a lot of work to be done. And what we also propose in that priority is that an exchange platform for the coordination and validation of the test guidelines for the European stakeholders could be implemented, with special emphasis on the interfaces to the Caracal Group and the Macrame Horizon Europe project, where this prioritization of the test methods is currently done. This platform could also provide training on test guidelines and standard development, because that's clearly a need that was addressed by industrial stakeholders and also from research and technology organizations. when we look on the later stages of the innovation processes, then there might be a good approach to establish these regulatory sandboxes. When we really go into new materials, into innovative materials, where it's not clear what is the existing regulation, is it sufficient enough? Then these, let's say, these kind of protected rooms for the upscale of the materials and also for the market introduction could be very helpful for the development of the higher technology readiness levels. Thank you very much.
Thank you, Christian, and thanks all the panelists in session 3, which I would like to close now with the online survey and the Q&A. Yeah. Gemma has already started.
So Peter, I think you can start taking the questions. In the meantime, we are running the survey.
Let me see where I need to start. Yeah, the first question is probably towards Andrea. We already have the Raw Materials Academy. Wouldn't it be better to create the Materials Academy including both raw and advanced materials instead of creating 2 different initiatives?
So the decision on the academies comes from the Commission, not from us. So we will work with the Academy. However, I take the chance of this question to make a distinction that we do not deal directly with raw materials. There is a raw materials partnership and initiative and so on. We deal with innovative advanced materials. And while there are overlaps and collaborations, also the skills may be different in the 2 cases. Clearly, we will work as a partnership, as an association with both academies and provide the feedback of our members to ensure that the training and the skills are developed in an appropriate way. Thank you, Peter.
Thank you, Andrea. So the next is probably more a comment from Tobias Schully. We will take this into account. Then we have from Lee Müller, which maps are existing in Europe and how to access them? Natalia, can you please answer this question?
Yes, thanks a lot for this question. I know that, for example, this big map, it is project, and in other case, it is really this map existing for Euro. It is focusing for battery interface and battery development. It is a lot of partners in this consortia, and it is available as battery testing and battery development in Europe. It is example, for example, for maps which are existing and which is accessible.
Okay, thank you, Natalia. So next question is, when it comes to fostering production, I assume production of, say, products, not production of materials. How is IP regulated when we use cross-linking ontologies? I'm not sure who can answer this. This is more like a legal question. So probably I will try to give at least a partial answer. Ontologies, IP on ontologies, to my understanding, this makes no sense. Because if an ontology is not freely available, you cannot use it based on this interoperability. By no means. So ontologies are probably not regulated by IP. Cross-linking tools are probably different. The interfaces should be open because otherwise you cannot cross-link, but the implementation might be closed, and how IP is regulated in this area is in the end a legal question, and I'm not sure if IAM4EU is the right place to ask for advice on that. Then we have a question on priority 20, which is towards Natalia, towards the large infrastructure or ITB and map integration. Priority 20 involves software that needs to be easy to use, integrated, and access. Can this be delivered by open source? Well, that's a tough question. European industry require well-maintained, user-friendly software, and Europe has key strengths in materials and manufacturing software industry. How will the initiative support and develop these requirements and opportunities?
Thanks a lot. Yeah, very good question. Of course. First of all, I cannot agree that open source is bad software. Sometimes you can really find open source which you can easily use. For example, OpenFOAM. It is open source, and the broad community are working in it and use it for different simulations and providing excellent results. Sometimes you need to have the support, and if you have a large infrastructure specialist, of course you will have. I worked here sometimes at DAISY, and it is software which is really complex. But we have a training session, training focus, and of course it is specialist support for infrastructure and software infrastructure as well. It is needed. Yes, I cannot say that each software open source software is ready to easy use and to be user friendly. All of us knows it is different level of preparation and usability of software. And thanks, very, very, very good request to be sure that industry can easily use this product, especially digital product, digital platforms, digital infrastructure. And it is special efforts which, of course, the association should bring and should consider. Thanks. Yeah, thank you very much.
Probably an additional comment from my end. I think this goes more towards the software industry, which and how we integrate tools from the software industry, which is obviously not open source, into this initiative. I think that the point coming from the regulatory pressure, which is coming from the ESPR and from other regulations as well, will in the end enforce software industry to collaborate as it enforces the manufacturing industry to collaborate along value chains. I do not see this too different. So those who are collaborating from as early as possible will simply have a competitive advantage when regulatory pressure shows up. This is at least my perspective. Okay, next question. Again on priority 20, so Natalia comes to the stage. How can advanced binders, specifically adhesives for consolidating industry waste before final classification, transforms the priorities and approaches in research and development of emerging technologies, especially when the context regulatory sandboxes for virtual worlds and 4.0?
It is really a very specific question, for specific regulations and how to integrate in the priority for large infrastructure. I think we need to discuss it per email and really address if it is in priority for this this aspect in this priority or not. To be honest, this is specific classification and specific materials. If it is in the range of advanced innovative advanced materials, we will take into consideration. Thanks for this question.
Yes.
But it is really extremely specific. Yeah.
Next question comes from the same person. Actually, two questions. The first one is innovation and development. How might these advanced adhesives influence? So it's again too specific. I think we should discuss this probably offline.
Yeah.
And the next, so 1, 2, 3, 4.
One
so
maybe
we shall discuss this. We shall discuss this probably on offline in the name of time. Then we have Sharif Maradour regarding priority 21. That's standards and norms. Christian, this is for you. How are digital twins being positioned in the context of standard and norms development? Are they envisioned as a key tool to streamline certification processes, reducing physical testing requirements, and accelerate both certification and development timelines for IAMs? Christian, would you like to comment on that? Of course.
We have them, of course, in mind. The digital twins, that was also mentioned in, I guess, session 2. As a key tool, I would say we are not that far in the discussion and the development. And also having in mind that we are speaking about new materials where it's with regard to standardization often not clear what test methods have to be applied, where we can get a certain kind of information from, and that's I would say topics to be discussed when we speak about acceleration of these processes.
Thank you, Christian. Then we have another question, probably towards best Andrea.
And then, Peter, we will close the Q&A.
We will close the Q&A? Okay.
Yeah, no, one more. Yeah, let's go for the next one, and then we will just discuss the results of the poll, and that will be
okay,
it.
Perfect.
Thank you.
So this goes towards you, Andrea. Would business models also be part of the Advanced Materials Academy? Well,
this is exactly,
thank
you. This is exactly the kind of input we need to make towards the Advanced Material Academy after we survey our members. My gut feeling would be that certainly business model targeting new innovative advanced materials, this was covered by the priority of Francesco, will be certainly useful for training of the new workforce. But this is exactly one of those inputs that we'll need to decide after we survey our members. And with this, I will ask Peter to show the survey and then close the session.
Okay, thanks. And I would like to thank all my panelists. And let's go on with the survey. Thanks.
Yeah, the survey is now on the screen, Peter, if you want to comment on it.
Yeah, let's have a look. So technology infrastructures seem to be really important, the widespread use of them, and those who are already on the stage. This got many votes. Astonished.
Okay.
Yeah, but I mean, we have a spread, of course, but I think all the priorities which you have on the table are important. So I think we can follow them up in the next iteration of the SRIA, right?
Yes,
thanks.
Certainly. Thank you very much, Peter, and thanks for all the panelists and all the sessions. We now have our scheduled break. I suggest we take 13 minutes, so we will start again at 12:25 in 13 minutes from now. So please don't disconnect. stay online. And please, in the meantime, we are going to take other questions after the break, and all the panelists will have to be back after the break because there will be questions across all the areas. See you at 12:25. Okay, so we are ready to restart. In the meantime, I will ask all the panelists to connect again and show their screens on. We will restart first with a general Q&A. So we are going to cover some of the questions that were not covered before and some of the questions that are more general in nature. We give it another minute and then at 12:25 we'll start. Okay, so we can start. So the first general question is, what is the meaning of technology neutral that was shown at the beginning? I will ask Jerome to comment on this.
Technology neutrality, materials neutrality. So we are a co-programmed partnership, which is by nature driven by industrial needs. And what matters to industry is to find solutions in the first place to their problems, regardless of the nature of the solution. So basically, regardless of the type of material or the type of technology, industry is not buying technologies, is buying a solution. So in that sense, being driven by industry needs, being a co-programmed partnership, we will implement whichever R&I activities that will support any types of materials, provided that you understood it is bringing up some viable solution, both technically and economically.
Thank you. I see Peter Klein also wants to comment on this question. No, it's fine. Okay, thank you. So we'll move to the next one. On materials, we manufacture lenses for anti-reflective glasses for virtual reality and augmented reality. They are key components and projects worth billions of for industry of billions of euros. And however, work in the EU Chips Act consider optics as something that is used in data transfer, like light cable coupling to industry. We have challenges to find an interest there for our challenges. For our needs, one part is material processing and the other is new materials. So basically, yes, it is correct that the CHIPS-EU deals with electronic and photonic devices, but not with AR glasses and so on. And two, yes, IAM and IAM4EU is the place where new materials can develop for these technologies, or existing material put together in a new way, for example, some new anti-reflective coatings that didn't exist before. So this would be the area of interest. The other question is, when is the 2025 calls going to be launched? I don't know exactly the date, but this gives me the chance to indicate the first areas that will be covered by the Work Program 25. This will be innovative advanced materials for photonics, enabling low power and ultra broadband performance for telecommunication networks, innovative advanced materials for conformable, flexible, and stretchable electronics, and innovative advanced materials for advanced coating, sealants, adhesive, and functional surfaces, innovative advanced materials for product monitoring, enabling smart maintenance and repair strategies. And then there are calls related to this, for example, AI and ML-based models, tools and services to accelerate innovative advanced materials design and to optimize innovative advanced materials compositions and structures. So those were developed by the existing acting board of IMI, but for Work Program 26 and 27, the new association, IMI, the new board, the new association delegation, we take care of this. Then we had these 4 questions that will be answered offline that were discussed before. And so another one is for Elmar. about advanced binders, and adhesive, can they be used to consolidate industrial waste before it is classified as waste? Elmar.
That's also this is a quite complex question, because here is intermixed the concept of binders, which we usually use as the matrix of some polymers, whatever, and adhesives. And so for me here is not clear what we're really referring to. So maybe it would be a good point to have a discussion with Pepe offline or per email or so.
Yeah, so then we will take the questions for Pepe. Betancourt, please email the relevant people, or if you just want me and Jerome, and we will take these questions offline. The other question still for you, Elmar. What is the difference in terms of materials used in the automotive sector in China and the rest of the producers? Is there a difference between the two?
I must admit I don't know. I mean, it's such a broad question. Many components in the automotive come from China. Many European industries have suppliers and manufacturing plants in China. It's a very much diverse question. There is not a yes or no or a simple answer to this. And automotive, I'm not from automotive. Automotive people might be the right persons to answer. We might look for it, so we can ask them, of course. But I admit that I'm not able to answer.
Okay, we will take this offline. Then we have a question for Peter Klein for P12. You have mentioned that hardware servers, who will be responsible for the hardware infrastructure required for the material data space, finance, support, maintenance? There seem to be very different views discussed on this topic, so clarification is important.
I'm not sure if I can clarify on that, and I'm not sure that anybody else in the IMI or IAM4EU partnership can answer this, because this goes a little bit beyond the scope of this partnership.
Okay,
we are not, and again, we are not for the capex of infrastructure. And of course, if you want to have servers, you need money in order to buy them. You need money in order to operate them, and you need money to maintain them. We see ourselves more as users of these kind of infrastructure.
So indeed, and however, we also see as ourselves, so rather than see, we will be the counterpart for discussions with the Commission to bring the community needs. Yeah. And surely, if there is a large need for infrastructure, we will ask the European Commission to provide a means of a funding or an action on this area. So we will definitely collect this information. And then there is
probably to extend on this. I mean, this materials commons infrastructure again is announced in the policy communication on advanced materials. So from my perspective, the Commission is in charge of setting this up to some extent.
So then there is a similar question. What about advanced facilities to provide input data for computational models up to digital twins? The similar story, as explained also by Amaya, we will do a survey of all the existing facilities, capabilities, try to make it easier for users to access them. And if we see some significant major gaps, we will be the first to go to the Commission and argue, look, there is this very significant gap. The stakeholders are all pointing in this direction. Let us talk about a potential investment in this area. And yes, and there is another question if this applies to graphene as well. Yes, of course, it applies to graphene and also all the 2D materials and so on. Those are fully part of the Innovative Advanced Materials Initiative. And then a question that is probably for Christian Seitz, is IMI going to promote any not-for-profit model for IAM's development and circularity or incentive system?
Good question. Thank you. It's not in the scope so far.
Okay, so we leave it like that. So not in the scope at the moment, but probably.
Yeah, it needs to be discussed because I would need some background on that. It would be great if you could make the connection afterwards.
Okay, and so we will take it under advisement. And then another comment, P18, which is for Amaya, is essential for all prior Ps and most for P17, where incentive should be, where one incentive should be that the people would hire and develop knowledge in collaborative approaches. New staff can often be hired as a result of collaborative projects where they are trained. In all our priorities, the training aspect by upskilling, but also by making our ecosystem attractive for new researchers, young researchers, and so on. We have to make the work in this technology attractive early on. The most strategic and innovative resource are people. A direction of resources should take into account these. SMEs, startup, new industry need a large pool of innovative staff that we have to generate by creating attractiveness to the sector. So we'll ask Amaya to comment on this.
Well, Andrea, this was in fact yours related to the academy, but yeah, of course, I mean, I totally agree. I mean, there is a shortage of skills in Europe in many different fields, and innovative advanced materials are included. I mean, there is a clear shortage. So to have an academy in line with those needs would be ideal. So we will take care of that also.
Yeah, I was mostly pointing to the part of the question that say that SMEs are in badly needed new skills in this area. But yes, of course, the Advanced Materials Academy would of course cover these aspects after surveys of the stakeholders. So we have done this. We have done the IP and business models. This was done. The topics and the slides will be all shared at the moment after the meeting. And how will the partnership collaborate with the Graphene Flagship Initiative? I will answer this question myself. So the Graphene Flagship is a key element together with Advanced Materials 2030 in the creation of IAM4EU and IMI. The Graphene Flagship will be fully part of the Innovative Advanced Materials Initiative, and we don't envisage to continue a separate track on funding only for the Graphene Flagship, but all the graphene and related materials activities will be funded for sure, and they will be relevant for IMI and IAM4EU. And this was already indicated in several of the priorities. And if you feel that some of the priorities are missing or topics are missing, please do send comments or questions. And I think we have answered around 170 questions at the moment, and I don't see any other questions that are relevant for this part of the presentation. There are 2 questions left, but those will be answered at the end because they are relevant for the next steps. So unless there are, I don't see any further questions. So I will now ask then Jérôme to outline the next steps, and then I will take the last 2 questions after Jérôme's presentation. So Jérôme, please go ahead.
Okay, yes. So you have had time by now to read the slide. So this offline survey is basically the same survey as the one we have just done, but a bit more detailed. And as I said at the very beginning, you will have a few days to complete it. You see, we are closing it on Tuesday, end of the day. So we are again going through these questions on which priorities you are supporting, and then asking you for each one some concrete information about what materials you have in mind, what types of components and products you are aiming at. Also ticking the application areas. You have done it already. Additionally, we're also asking you to estimate the range of TRL you are envisioning as where to be supported, sorry. And also the last question regarding private investment. There is a yes and no tick boxes, but in case you foresee any investment from your organization, please try to quantify this as much as you can. And this is covering the 3 years period from now until the end of Horizon Europe. So as said, these slides will be shared with you, I guess, this afternoon. Once we are done, we are finished with the webinar. So you will be able to retrieve the link, the internet link to that survey. You have the QR code as well. So please take the